Have you guys talked about splitting up between the sections? I saw you posted in Slack about. Okay. 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 Sweet. Cool. Because yeah, I don't think there's any reason for you all to be here for both sections. Yeah. Sounds good. Cool.
Now that this is a 200 level class, can people take it for the minor?
I think so, yes.
Cool.
Yep. I think that's probably why there's so many.
Right.
So, yeah. Trying to figure out exactly. I think everything that we covered when you took it in the 100 level, we'll do in about half the time.
Okay.
And then we're going to do more JavaScript, and we'll get into React as well on top of it. So I think it'll be fun.
Exciting, yeah.
Yeah.
Yeah, I've never done React, actually.
Oh, yeah. Yeah.
Complicated or?
It can be kind of complicated just to set up, but once you sort of get everything working, it's really nice. It lets you represent like components in your JavaScript, like so HTML components or even native components. You can do React Native where it like compiles to iOS or Android, which is nice. But so it lets you like you can change your data in JavaScript and it's automatically reflected in your HTML. So you don't have to like write back and forth and say, okay, now I'll write this. Like it just kind of handles it for you. So, but there is some like annoying setup you have to do. So once you get all the like setup out of the way, it's pretty easy to work with. So
yeah, there were a bunch of people doing React Native at the place I was working this summer.
Okay, gotcha.
They seemed like the most stressed out of everyone.
Yeah.
Maybe whatever they were doing was more complicated. But.
Yeah. Yeah. So was it like a marketing agency type place or?
Well, no. So they would actually make like websites and apps for other like either startups or
gotcha.
People would just come to them with like an app idea and then they would like design it and develop it.
Okay, cool.
For them.
So did you get to work on a couple different projects or?
Yeah, I got to work on 2 projects.
Nice.
I was abroad last semester.
Okay.
And I got back like end of June.
Yeah.
So I only got to do 8 weeks there.
Okay.
Which is a little shorter than a normal internship, but still a good amount of time.
Yeah. That's awesome.
Yeah.
That's the nice thing about working at a firm like that is you get to kind of work on different stuff all the time.
Yeah, totally.
And get a lot of broad exposure.
Right.
That's nice. All right, let's go ahead and get started. If you guys need help with any of the setup stuff, by the way, come see us after class. I'll stick around. So yeah, also if you need, does anyone know if you can put the screen on the other TVs? Should have looked into that. I'll try and figure it out. But if you need the YouTube URL, it's not up there. It's like youtube.com/c/Kraig Hufstedler/live if you want to pull up the live stream. And then you can see the slides on your own computer. I'll also publish the slides on Canvas in a PDF after the lecture as well, so you can get them there. Okay, we're we're going to get started. We're going to try and cover quite a bit today, mostly talking about just kind of general web development concepts, talk about web hosting, talk about how HTTP works, talk a little bit about HTML. So anything that I've bolded in the slides are stuff that you should probably, become pretty familiar with because it might be covered on a quiz. But in general, I'll cover some lists of things and stuff. Don't feel like you have to memorize everything in the slides and try and make it pretty clear what exactly you need to memorize. So don't go too crazy writing everything down or anything. I'll kind of hit on what's really important and what's just kind of general info. Okay, so first of all, this thing's gonna have a delay, isn't it? How bad is this delay gonna be? Okay, I'll have to change slides really prematurely. So first of all, I'll just talk a little bit about some of the different ways that people access websites, right? So the ways that people access websites definitely informs how we develop websites. We definitely have to keep different types of users in mind. So obviously we have web browsers. That's the primary way people access. So Chrome, Safari, Firefox are kind of the main ones at this point. Internet Explorer still exists, and a lot of people use it. But the newest IE at least is relatively more modern and in line with standards. If you ever have to deal with like supporting older Firefox or older Internet Explorer, IE 9 or IE 10 even, you start to get into some problems. It was just a lot different, so you have to do some things really specific for IE. So if you're ever applying at a job and they ever talk about like IE 8 or IE 9, run as far away as you can. I've had that happen to me once where I was at a job, the CTO used a really old computer that had IE 9 on it, and he looked at our website that we built and was like, guys, this doesn't look good at all. And so we literally had to spend 3 weeks, a team of 5 of us, integrating IE 9 into our site so that he could look at it rather than just buying a computer. So really annoying. Mobile devices obviously are also important to keep in mind. They have varying screen sizes. Mobile devices, different orientation typically. They also have different interaction behavior. So instead of scrolling with the mouse wheel, you're scrolling with your finger. That interacts a little bit differently. You can't do things like hover with a mobile device. They can't detect where you're hovering your finger. You don't know until they've actually clicked. So things act a little bit differently when dealing with mobile device. We have to keep those in mind. Also, a big thing that we need to keep in mind as well is screen readers. So screen readers are software that will read aloud the contents of a website or the contents of a screen. So they're used by those with visual impairments. They'll read the contents aloud. So the ADA, or the American with Disabilities Act, provides a lot of guidelines for designing websites to be accessible. So especially if you're ever working at a larger company or any sort of government organization, that's a pretty big concern because they're actually required by law. And I think it's changing from recommended strongly to required here in the next year or two, I believe. So a lot of companies have been really gearing up their accessibility features to make sure they're in compliance with the law. So we have to keep in mind screen readers. So there's a lot of things we have to do on our web pages to make sure that screen reader software that's reading through the HTML can make sense of what's going on and can accurately reflect that to users. So things like images, we have to provide some additional content in text format explaining what the image is, things like that. We have to make sure even just our HTML being well formatted can make a big difference with how screen readers read it. So really important that we keep that in mind. So I'll kind of point out those features as we go along throughout the class of what we need to do to keep screen readers in mind. This is I forgot to change it. I might have to switch back to something else instead of YouTube. Okay, so this is analytics.usa.gov, which is the government's analytics website, and they provide this just to the public. So you can go to that website. This is from last year, so it's probably a little bit different now. But just kind of shows us a general breakdown of the types of devices that people are using. So obviously desktop is at 55, mobile's not far behind at 40%. If someone wants to pull it up real quick so they can tell me what the current breakdown is, I'd be really curious. I would guess that mobile's up more around 45% if I had to guess. Mobile's only growing and increasing in its share. So you want to have that pulled up? Okay, that's definitely more. So it's growing, 2% per year or so, 3%, I guess. So obviously a big deal. Tablet, not as big of a market share, but probably also growing. We can see Chrome is by far the most popular browser. That's changed quite a bit over the last probably 5 years or so. It hasn't been around all that long. Followed by Safari and then IE. Obviously, we see IE 8 and 9 are thankfully almost gone. Followed by Firefox, and Edge is the name for the newest Internet Explorer. So they stopped at 11 and then they renamed it Edge. So when you see Edge, that's the new Internet Explorer. We also see operating system breakdown. Obviously, Windows is huge. They don't really show mobile Windows, which I guess there's probably not a lot of people using Windows phones anymore. But iOS is a close second. So there's more iOS users than there are Macintosh users, which is kind of interesting. This goes to show, and if you go to the actual website, you can see a lot further breakdowns. They'll show you demographics. You can, isolate different segments and look at the breakdowns there. They provide, quite a bit of information. But the main thing to keep in mind is just that there's obviously a very broad combination of devices here that we have to keep in mind when we're developing websites. You can't just build, a one-size-fits-all website. For the most part, all of these, browsers and devices follow standards, and they should render websites pretty much the same in theory. But in practice, there's a little bit of difference between each one. Chrome and Safari actually share the same. I think it's Safari uses Chromium or whatever. They share the same rendering engine, so they should be pretty similar. Internet Explorer is a different rendering engine. It has its own, and Firefox is a different rendering engine. So the way that the actual software that interprets the HTML and draws it on the page is entirely different for those three browsers. So again, in theory, they should do it exactly the same, but in practice, you'll find there's quite a bit of fine details that can be different, sometimes in unexpected ways. Because sometimes the standards don't cover every single case, and so the browsers kind of have to decide how they're going to interpret a standard. So one other thing I wanted to point out on for a different website. So this next one coming up is a website that I worked on for a local church, and they have a little bit different analytics. So they have 55% mobile and 37% desktop. So I found it interesting when I was looking at their analytics because you think about it for more of a local, like, nonprofit type of situation, a lot of people are probably pulling it up on their phones, trying to find directions, things like that. Whereas a government website, if you're going to the IRS website, you're probably not pulling it up on your phone, right, to pay your taxes on your phone. So a little bit different demographics. So I think you'll find that, I think if you're working on, like, a local business website or probably even WashU's website to some degree, smaller localized type websites, you're going to deal with a lot more mobile traffic. So I was shocked when I pulled this up and I was like, they have more mobile users at this point than they have desktop. So I spent a lot more time making sure it looked right on mobile because they have a very high percentage of mobile users. So this is coming from Google Analytics, which is a really nice tool, by the way. If you are building a website, all you have to do is include a little JavaScript snippet, and it will show you that breakdown. So really useful to have. Every website I've ever worked on, or at least recently, I make sure to load Google Analytics so I can see that breakdown and kind of see what the user behavior is. Okay, so let's talk about web servers and kind of where websites come from. So the internet works on what we call a client-server model. So clients are what we call the browsers that are accessing a resource over the internet. So if you hear like front-end development, back-end development, front-end is the client. So that can be your browser, it can be your mobile device, whatever. Servers are the computers that host the resource, such as a web page, or sometimes just a file. So servers really are just computers. They're specifically built to handle, many requests. They're usually built in a certain form factor. But really, they're just computers, not that much different than the hardware that's in your computer. It's just specialized to serve lots of requests. So again, back-end development, this kind of front-end, back-end is kind of a newer phrase. But backend refers to the server side of things. So we have clients that are accessing websites, and we have servers that are providing the websites or serving them. So we use special software on the web servers to serve web pages. So Apache and Nginx are the two most popular. So that's the software that runs on the servers that actually replies to requests and handles the HTTP stuff. They can also use any operating system. So Windows, Mac, or Linux all have server variants that will run as servers. Linux is probably the most popular, so you see a lot of Ubuntu, CentOS, stuff like that on web servers. So then web hosting companies, they just have their own large specialized web servers that they manage for you, and you can pay them for a portion of their web server. They'll host the website for you on their servers, which is much more efficient typically than, having your own server somewhere in a closet and having to deal with, maintaining that. Here's a picture. Once the delay resolves itself. Here's a picture of some web servers. These are what they look like, at least a lot of them on a large rack. And then really each one of those slots is just a computer that's just in a certain form factor. This is kind of what an individual server looks like. So if you're familiar, if you ever built a computer, you'll probably recognize some things. There's a hard drive, there's a disk drive, your motherboard's kind of over here. You can see the RAM. It's just a computer. There's nothing, that different about it other than its form factor, and it's built to slide into those racks so that you can have, 20 or 30 of them in one cabinet and manage all the, cables and networks and stuff. So it's just kind of a lot easier to handle. Any questions so far? Feel free to, raise your hand at any time too. If I see, I'll answer your question. Okay, so web hosting. So for a website to be publicly accessible, it needs to be hosted on a publicly accessible web server. You can have your website on your own personal computer, but I can't access it over the internet because I can't access your computer over the internet. So we have to make our server publicly accessible. So web hosting is kind of an economy of scale. So large data centers can host thousands and thousands of servers and do so a lot more efficiently than you or I. I have one little server at my house, and it uses a lot of electricity. It generates a lot of heat. If something breaks, I have to maintain it. I don't host anything important on it because if something breaks, it could be down for days while I order a new hard drive or whatever. But in a super large-scale data center, they combine everything. They do water cooling. They can have giant air conditioners. They can have full-time staff that's going around maintaining things. It's a lot better, as well as physical security. If I host anything, important on my server, I'd want to lock it up or make sure that no one has access to it. At a large data center, they'll have, fingerprint scanners to gain access to the building, things like that. So, really, the larger, the more efficient they can manage lots of servers. Virtualization is important to talk about. It's a software technology that lets you run many virtual machines on top of your hardware. So each of those virtual machines will have access to a portion of the host machine's resources. So most website hosting companies at this point operate this way. So they'll have large servers with lots of resources, big processors and tons of RAM and tons of hard drive, and then they'll run virtual machines on top of that. So they might have 50 or 100 virtual machines running on one server, and each of those virtual machines has access to a slice of the resources for the full server. And you can even at this point span multiple servers with a virtual machine. So Amazon does this, and Google as well. They'll create virtual machines that have access to the resources of 2 physical servers or 50 physical servers. So now you have a giant virtual machine that has all kinds of resources available to it. So it's really, really flexible that way, and it's all software defined. And it's also pretty robust as well. You can have your virtual machines running on redundant hardware where if one hard drive crashes, it doesn't really matter. They can just move the virtual machine to a different physical server, point it to a different hard drive, and it's all fine. So pretty much any web hosting company at this point will operate this way. You can still buy, dedicated servers, but it's quite a bit more expensive. So if you see the phrase VPS, that means virtual private server. It's the same thing. Hypervisor is the software that manages the virtual machines. So like VMware or Zen, these are common ones. You can even run virtual machines on your own laptop, and I do for work. So like we have, our software that we develop at work runs on Linux, and it has some really specialized setup that the operating system has to have. So I run Linux in a virtual machine that I have my application installed on. So like VirtualBox is what I use. So you can just download Linux and install it in VirtualBox, and it'll spin up a machine that you can then SSH into, and it's a full Linux environment. So that's a really popular way of doing localized development when your application runs on Linux or has certain specific needs. Okay, so cloud web hosting. It hasn't switched over yet. We hear the cloud or the term cloud a lot. Typically, it just means nearly an unlimited pool of resources to draw from. Amazon, they have probably dozens of data centers at this point, all across the country. All of them with hundreds of thousands of servers in them. So you have access to that entire pool when you're creating virtual servers within Amazon. So cloud providers also usually provide scaling. They provide really neat management tools, other services like your DNS, things like that, databases, that kind of thing. So AWS is probably the biggest by far. So if you're not familiar with AWS, and you're interested in learning more about web hosting, they're definitely one to look into. They also have a free tier, so you can run like one virtual machine for about a year, one of their smallest ones for I think a year for free. So it's pretty nice. And Azure and Google Cloud both have some free resources available as well. DigitalOcean's also a good one. They're a little bit smaller, a little bit more hands-off, but simpler in some ways. Amazon Web Services is almost overwhelming, just the amount of things you can do. It's kind of hard to sort of acclimate to that environment. So some pros of doing, cloud web hosting, it's usually cheaper. You usually pay for usage. Amazon even now, you can pay per compute cycle almost. Like you can get really specific with your payment and what you're actually paying for. So again, if you think about the cost of buying servers, say each server costs $2,000 and a server rack costs $1,000, and you've got to provide the electricity, you've got to provide the internet connection. It requires a fast internet connection and a fast upload speed in order to host a web page. You could pay for all that. You could, sink tens of thousands of dollars into building your own little server thing, or you can pay Amazon their biggest, or the servers that we pay for at work are like $5 an hour or something like that. And if we stop them all, we won't get charged $5 for that next hour. So it's literally pay as you go, pay for exactly what you use. So it's really, really nice, and it's cheaper in the long run. Again, easier to set up. You don't have to deal with like plugging things in and dealing with hardware. Also, usually are automatically managed. So like Amazon will send us emails if there's problems with our servers, and they'll move stuff around. They do a lot of automatic stuff for you. There are some cons. There's some security risks. So, with virtualization, some of the biggest security issues that the web development community has faced over the last few years are related to virtualization. So if you think about it, you're running on a shared server. You have a slice of a hard drive, but if you were able to find a way to break out of your virtualized environment into the other resources running on that same server, that's quite possible. So a lot of them have to do with memory leaks. You could read the memory of your host machine, and that usually includes data from other, clients using that same machine, or reading the hard drives. Because again, if you have a virtualized environment, you're getting a slice of a real physical thing, and if you can break out of your little slice, you can grab some data from somebody else. So there's some security risk for sure. You also have less control with cloud environments. There may be things you're not allowed to do. You can't select exactly what kind of hard drive you want. You're just kind of stuck with what they give you, things like that. You also have some vendor lock-in. That's something that we're finding more and more now. Is a lot of companies have just jumped headfirst into moving to these cloud providers, and then maybe they decide down the road they don't like their pricing. Well, it's really hard to move from one cloud provider to the other. There's some tools available now that make it a little bit easier, but you get some vendor lock-in, and that can be a real downside. It's harder to move away from that cloud provider once they're fully in their stack. Okay, questions about that? Questions about cloud providers? Okay, so websites are accessed by a URL, which stands for Uniform Resource Locator. The URL consists of a couple of different parts we'll talk about. So first is the protocol or the scheme. So that's the HTTP or HTTPS. HTTPS being for secure connections. They decided, okay, how do we indicate that it's secure? We'll add an S to it, and now it's secure. HTTP stands for Hypertext Transfer Protocol, and HTTPS stands for the same, just with security involved. The domain is the main address of the website, so that's like your google.com, your wstl.edu, facebook.com, those kinds of things. That's the domain. They may include a subdomain, so when you see like www. The www is the subdomain. www comes from kind of an older way where it stands for World Wide Web. It's just a convention. There's nothing magical about the www subdomain other than a lot of websites use it. So it's pretty common. Or like docs.google.com, something like that. Those are other subdomains you might run into. The .com part is called the top-level domain. So there's many options for that. They've even opened it up over the last couple of years. It used to be you had .com, .net, .edu, .gov, and that was about it. As well as ones for different countries, .us, .co, .uk, or whatever, for the UK. But in the last few years, they've actually opened it up to a lot of different options. So you can have, now if you search for, top-level domains, .io is really popular. But you can have almost anything up to like 4 letters at this point for your top-level domain. But there's still, you can't just choose it arbitrarily. That has to be, your domain registrar. You choose that, and there is a finite list of options. It's not, completely up to you. After, your domain, your top-level domain is the path of the file name, so / folder / index.html. It doesn't always include a file extension. HTML will just be the default. So if you go to google.com/search, there's no .html, but it is going to return HTML because that's just the default. And a domain with no path is called the root of the domain. That's an important thing to know. So like if you just go to google.com, you're going to the root versus google.com// which would be like a subpage or something like that. Questions about URLs? Okay. Here is a chart that kind of goes through that. So again, we've got the scheme or the protocol. We've got the subdomain, the domain, the top-level domain. Sometimes there's also a port. If you've done any like Node.js stuff, usually it uses port 3000. You don't have to include the port with a colon there, but sometimes you'll see that. And then you've got your path. You've also got a query string we didn't talk about, so that's an option as well. If you're, like sometimes search will provide a query string with your search term, things like that. And there's also this fragment identifier, which we'll talk about a little bit later when we get into some more HTML stuff. So that's what a URL looks like. Should look pretty familiar, but now you know kind of what each specific part is called. So one thing that's important is DNS. So your computer, to access a website, it needs the IP address of the server hosting the website. So when you go to google.com, your computer actually needs to connect to an IP address for google.com. So it does so this is what IP addresses look like. This is IPv4, which is kind of the older style, still used. And this is IPv6, which is the new one. We've actually run out of IPv4 addresses, or at least we're very close. You can see there's not all that many combinations, and now with every single device that connects to the internet has an IP address. So every phone in this room, every computer in this room has its own unique IP address. With the explosion of mobile phones and especially Internet of Things devices, IP addresses have very quickly run out. So IPv6 is a hex-encoded method of doing IPs that provides for many, many, many more combinations. And so that's kind of the new standard. So everything here pretty soon it's going to become mandatory to support IPv6. At some point in the next 5 years or so, we'll switch from primarily using IPv4 to using IPv6 instead. It's a lot harder to read though, obviously, longer. So again, after you type in a URL like google.com, your browser first queries a domain name system or DNS server, which knows what the IP address is for that domain. So a DNS server is kind of like an address book for the internet. So it has a domain, and then it has the IP address that is associated with that domain. We won't get into too many details, but as a web host or as a web administrator, you can set those in your DNS management. So if you've ever bought a domain, if you go to like Namecheap.com or GoDaddy or something like that and buy, if I bought KraigHufstedler.com, I can indicate what the IP address is, and my web host will broadcast that as the DNS record for that domain. We won't get into the details, but there's a lot of stuff you can do there. So again, those DNS servers are run by internet service providers typically, or large companies. So like Google has their own DNS servers, as well as like Charter or whatever your ISP is. They'll run a DNS server for you. They all share information. So, if one DNS server has, an IP address, it's what we call propagation. So usually when you first set your DNS settings on your website, it takes like anywhere from like 5 minutes to 5 hours or so before everyone around the world will reliably get that same IP address for that same domain, because it takes a while for all the DNS servers around the world to copy that information and migrate, the data. So in theory, every DNS server that exists should have the same exact DNS records for domain to IP. Yeah, question?
So like a DNS server is like a dictionary of IP addresses?
Yeah, exactly. Yep. You can also run your own DNS servers. So like we do for work, like we have what we call internal DNS, where we have some domains that aren't publicly used. They're only used for us internally within our own network. And so we run a DNS server that says, okay, Craig's test server points to this IP and Sam's test server points to this IP, and it's only internal. The broader internet doesn't ever get those DNS records. It's just run internally. So it's like our own private dictionary. But yeah, your large companies, your internet service providers. You can also change, like on your Mac, you can change what DNS servers you use. I actually recommend switching to Google's or like OpenDNS. I think Google's is like 8.8.8.8. And it's a little bit more reliable typically. By default, your computer will just use your internet service provider, but usually Google's are a little bit faster and more reliable than your ISP. So you can look into changing that if you want. This is a graph in a minute showing how DNS works. So again, your browser, it will first query the DNS server and says, what's the IP of foobar.com? The DNS server will respond with the IP, and then you can make the request to the actual web server by its IP address. Your browser also will cache these, so you don't make this request to the DNS server every single time you go to google.com. Your computer maintains its own kind of local cache, so once you've gone once, usually your browser remembers, okay, google.com is this IP address, and that will expire after so many days or whatever. Or if it can't find it, then it'll recheck the DNS server to make sure it has the correct one. So going along with how HTTP works, once your computer knows the IP address for the server it's requesting, it makes a request to that server. An HTTP or hypertext transfer protocol is a protocol used by the client and server to talk to each other. So the client makes the request via HTTP, and the server returns a response via HTTP. There's a few other protocols, FTP, which is file transfer protocol, you may have heard of. That's similar to HTTP, but a little bit different. There's a few other protocols that aren't near as popular. HTTP is the one that the web uses. So an HTTP request, which is what your client sends out to the server, contains several parts. So first, obviously, the URL, so what we're requesting. Next is the HTTP request method, or sometimes we call it the verb, which is the type of request being made. So get and post are the two most common. Get is just the most basic request. You're just fetching a resource. So get requests should have no effect on the server. They should have no effect on the data. It's just purely, here's a URL, return the resource. It's just fetching information. Post, however, is how we submit data to a server. So it's how we say to the server, here's some data. I want you to store it or process it or do something with it. But we're sending information to the server, not simply requesting. So post request will have some effect, in theory, on the server. It'll save it or it'll change some information. So think of like sending an email. That's going to be a post request because you're sending that data. Adding a post on Facebook, that's a post request. Writing a new tweet, something along those lines. Those are all post requests. There's other options. So there's other request methods. So there's head and put and delete options and patch. They're pretty rarely used. Head may be used a little bit more. All it's saying is return the headers of your response and don't return the actual body of the response. Or put, which is saying like, here's a complete object. Post can be any sort of data, but put is kind of saying like, here's a full data object of some sort that I want you to store. So it's, a little bit less flexible. Delete is maybe deleting a resource. I've used delete a few times, especially with like an API or something like that. You might use delete to indicate that you want a resource removed. Or like options where you're querying the server and saying, what are some of the different requests that you allow, things like that. So again, we won't really cover those at all in the scope of the class because they're pretty rarely used. Here's a kind of a brief example of, what some, verbs might look like for your HTTP request. So say you're interacting with some sort of store. So you might make a GET request to /store/inventory, which you're requesting the inventory of items that the store sells. You might then make a post request. Say you see an item you like in the inventory, you click, add to cart or checkout or something like that. You then make a post request to /store/order. So you're sending to that order, maybe in your post, message is like the items that you want, or something like that. Maybe it's a list of 3 items that you're, wanting to order. So that you're sending data. You're saying, here's some data that I want you to process. The data is the items that you're ordering and maybe your credit card details and things like that. You're sending all of that to the server for the server to process. You might make a GET request to like /store/order and then some order ID like 1234, and you're just saying return to me the details of this order ID. So you're not making any changes to the order. You're just saying making a GET request to get the details, maybe to do the tracking or something like that. Say you want to delete it, you might make a delete request to that same URL. So again, it's the same URL where you're sending to store and order and then 1234 or whatever. But because it's a delete method instead of a GET method, you're telling the server to do something different. You're saying delete this resource rather than return this resource. So that's why we call the request method the verb. That's kind of where that term comes from, because it's kind of what we want to do on that resource, whether it's get or post some information. Questions? Get and post? Okay. So some more information about HTTP requests. So along with the URL and along with the method, there's also request headers that are sent as well. So these are a few examples. You don't need to memorize these or anything. There's a ton of other options here, and most of these, some of them are required, some of them are optional. Again, your browser handles most of these. When you are doing working with an API in JavaScript, you might have to deal with some of these request headers and add them to your request in JavaScript if you're doing like Ajax or something like that. So there's like the host, which is the domain name of the server the request is being sent to. Like accept and accept language are saying, here's some information about the content that I want back. So you might pass accept language. That's the language you're requesting the content in. So if the server can handle multiple languages, it will then respond with whatever language you've requested. Cookie, you're sending it's data that the server has previously sent and requested the browser to save and to include with all future requests. So you send those as a header. It's commonly used for like user or session IDs as a way to identify what user is using the website. Also security tokens or like tracking information. You may have seen it like it's been a couple of months ago now. Like every website ever had a little notice on it about cookies, and that was due to some changes in the law in the EU about how you notified users about cookies because it's a privacy thing. So cookies can be used to identify your user. And what gets really tricky is when different websites can share cookies. So, for instance, if you go to, just as an example, if you go to Amazon.com, Amazon and say Facebook, let's say you're logged into Facebook, you're a Facebook user, you have Facebook. Facebook sets a cookie in your browser that identifies your user. It's possible for Facebook to share those cookies with Amazon. They probably don't, but just in theory, in this example at least, it's possible for them. So when you go to Amazon.com, Amazon can look up your Facebook information because they also know what Facebook user you are. So they can do some really targeting advertising and stuff like that. It's actually really common. A lot of websites you go to will get some sort of tracking information from third parties that they can relate to other services. So, a blog that you visit may be able to use your Facebook information to tailor ads to you because they know a lot about you simply because you're logged into Facebook in another browser tab, things like that. So obviously you get into some really tricky privacy situations, and that's where the EU took a pretty hard stance on the way cookies are used and definitely the way users are informed about cookies. So that's why you saw those pop-up notices on every website because the EU changed their laws and said you have to tell users really explicitly if you use cookies, what you use them for, and how you use them. So cookies are a really tricky thing. But they're sent to the server as a HTTP request header. Also user agents, so that's a string of information about the client. So it includes like the browser version, the browser details, what company made it, as well as your operating system. So every website you go to, that website knows exactly what browser you're using. They know exactly what kind of computer you have. They know if it's a mobile device. They know if it's iOS or Android. So it's really useful for some things. It lets the website kind of tailor the experience to you if there's certain things that need to change. It also has privacy implications as well. User agents are really, really specific, surprisingly, because they include your browser version and your OS version. So if I go to two different websites, my user agent relatively uniquely identifies me because I probably have a slightly different version of Firefox than everyone else in this room, just because of updates and things take time to get updated. So websites can use your user agent to relatively uniquely identify you. There's a website, I'll have to look it up and send it out to you later. There's a website that shows you your user agent and kind of gives you a grade of how unique your user agent is. So you can kind of see how well websites can identify you just by your user agent alone. But that's sent to every request as a request header. There's also content types, so that'll be used with post and put requests to identify what type of content you're sending in the request body. So if you're like uploading a file, you'd use a content type header in your HTTP request to say, here's the file type that I'm sending. Yeah, question?
So, say you're using Chrome, does the user agent also contain information about the size of extensions you have?
Yes, it does. A lot of times, it can include extension information. There's a few other things that it can include as well, but yeah, it can definitely include some extension
So
stuff.
is that why now places like CNN and other websites now know when you're using ad blocker?
That can be part of it. Usually, they use other ways to determine if you're using ad blocker. They can kind of run some tests in the JavaScript to see if things are being blocked or not. So yeah, that's a good question. Okay, so we've talked about the URL that we've sent. We've talked about the HTTP request method or the verb that we're using along with our request. We've got our headers. that are being sent with every request that includes some sort of meta information. The next thing is the request body. So this is only used for put and post requests, or any sort of request that's actually sending data to a web server. So the body is what actually contains the data that we're sending. So it can be in many different types of formats depending on what kind of data you're sending. So application /x form URL encoded is kind of the most common. If you have a form on a website, it's usually sending a post request using this format. You can also do JSON. So JSON is just a data format that you'd use with interacting with an API a lot of times. So that might be a format. You can also just send plain text or like an image if you're uploading an image to Facebook or something like that. The HTTP body would be that JPEG image type. So again, we really only have to worry about that for put and post requests. They're actually sending some sort of data. If it's a GET request, there is no body because all you're requesting is a resource. You're not sending any data along with it. Okay, so once the server has received our request, it's processed it, it's run through its server, software. It's run any Java or PHP or whatever it needs to determine what the response is. It then returns the HTTP response. So it contains several elements. The first of which, and the most basic of which, is the HTTP response code, which is a numeric value that indicates the status of the response. So it's basically a really quick way for the server to say if the response was successful, or if there was an error, or something else is going on. So there's some different responses here. 200 is the most important. So if you ever see like 200 OK, that's a successful response. The server is saying, we got your request, we received it, we're returning something. So it's a successful response. It may be an empty response. So like if you search on Google for something, just a string of random letters, Google may not have any results, but they'll still return a 200 because there were no errors in the request. There were no errors in the response. They're like, okay, we got your request. There just wasn't, we don't have any results, but it's still a 200 because everything worked okay technically, right? So 200 doesn't necessarily mean you get what you want, but it means that you've gotten something successfully. So it's pretty important. We deal with that a lot when you're dealing with APIs, and doing stuff with JavaScript. You might check to see if the response is a 200, and if so, you can process the response because it was correct. 301 indicates something is permanently moved, or 302 is it's temporarily moved. So those are relatively common. 404 you may be familiar with. That means file not found. So if it returns a 404 response, it means whatever URL you went to, it wasn't found. I don't have that resource. 500 is important too. That indicates an internal server error. So that means something went horribly wrong on the server, and it didn't return a correct response at all. So again, when you're dealing with an API and you're making calls to an API in your JavaScript, if you get a 500 response, you know that there's probably a bug somewhere with the API that you're dealing with, or you formatted something incorrectly, but something bad happened. So if you get a 500 response that you should change something or you should try again. Something bad happened. You didn't necessarily do anything wrong, but there was an internal server error. Usually means there's a problem on the server itself. There's several other status codes. You'll kind of see a pattern. 200 responses indicate some sort of success. There's also 100 responses, but they're not as common. They're just informational. But 200 are success. 300 indicates some sort of redirection. There's some new ones. There are 300, 307, 308 are more for redirects. 400 indicates some sort of client error. So something's wrong with your request if there's a 400 error. Whereas 500 indicates some sort of problem on the server. So there's nothing wrong with your request, but the server messed up. Something blew up, and something is terribly wrong. So again, those are mostly, the browser knows what to do with these. Your browser will handle these. It'll show a 404 page or something. But when you're dealing with an API, you have to kind of manually deal with each of those statuses. Okay, so along with the status code is a header in the response. So the same way that you send headers with your request, the response also contains headers that we have to deal with in some way. So like these are just examples. It's not an exhaustive list. Not all of these are required. You don't have to memorize all of these or anything. But age will indicate the age of the content if it's been returned from a cache. Expires is kind of important. So that will indicate how long the browser should save the page. So you can use this to tell browsers to save a local copy of that web page in the cache for X amount of time. So really common to at least put 24 hours on the expires, at least if it's not a really interactive page. So like Facebook will not have an expires header in their response because Facebook updates nearly constantly, right? They don't want you to save. The next time you go to facebook.com once, you see some content. The next time you go to facebook.com, it should be different. So they will not include an expires header because they don't want the browser to save local copy. But say it's like, even like WashU. I was looking last night, I think WashU's page has a 24-hour cache expires. So what they're saying is that for 24 hours, you can be pretty confident the contents of this page will not change. So the browser can save a local copy. So if you go to washu.edu again, maybe an hour later, your browser will just load it from its own local copy, and it doesn't have to make the network calls to load the page. So that saves you time. It's way faster to just load up a local saved cached copy than it is to request a copy over the internet. So I use this a lot. I had a client recently I built a website for, and they had a lot of features that they wanted, like some animation and like some crazy images and stuff they wanted on it. So it was kind of a slow page to load because there was a lot of content, there was a lot of JavaScript, there was a lot of images that loaded and moved around stuff. It was kind of a crazy web page, and it took like 4 to 5 seconds to load, which was kind of on the high end. And he was like, I'd really like to, speed this up. And so I was like, okay, well, I'll just add an expires header. And I was like, how often do you think you're going to change the web page or update it? He's like, I don't know, maybe like once a year or so. Like I probably won't update it for quite a while. I was like, okay, great. I set like a 3-month expires header on it. So I said that expires 3 months later. So for 3 months, you'll get the same exact web page until it updates. He's not updating it very often at all. It doesn't really change. So the page loads really fast now. The first time, it takes 4 to 5 seconds, but every subsequent time, it takes milliseconds because all it has to do is load it from its local saved copy. So it's a really good way to kind of speed up your website. You usually don't want to do 3 months because usually websites, reply or change a little bit quicker than that. Yeah, question.
What happens if you have an expire header, say like 3 days, but the website updates after like 1 day?
Yeah, so you may be out of date. It's quite possible that your browser would just load the local version, and that you just wouldn't get the updated content. Sometimes some browsers will do some sort of checks to see if it's changed. It may request, this is where age can be useful. Like the age may indicate how long a website has been in a certain state. So your browser, when it's loading from cache, may make a head request. We talked about, head as an option, and it'll get the headers back, which includes the age. So it may compare the age with the expires of the, current one to see if it's out of date or not. I've done that on some websites, so it's a way to make sure that you have a cached version unless the remote version is changed, and then it will update. Also, browser caches, honestly, your browser can only save so many websites locally before it runs out of space, and it has a limit to how much it'll save. So at some point, that cache will roll over. Usually, it's a matter of weeks before it's just gonna have to clear out the cache and update new stuff. Also, the users can clear their own cache as well. So that's a good question. By setting a high, expires response header, you may run the risk of users seeing out-of-date information. It's definitely possible, but there's some methods to avoid that as well. Content language, you can indicate the language of the content. That can be useful. Your browser may, know if that language is different than what your browser is. Your browser may give you options to enable translation or something like that. Content type is what type of content it is. Server is interesting. It indicates the type and the version of the web server that generated the request. We've actually found that it's safer usually not to include. It's usually enabled by default, but there's some security reasons you don't want to broadcast what type of server you have and what version it is, because if you're out of date, now everyone sees, okay, they're using Apache, 2.1 or whatever. That's out of date and has this specific vulnerability, so I can attack that server now that I know what version it is. So you actually don't want to usually broadcast the version of the server. So we don't use the server header as much anymore. Set cookie will provide the cookies that should be saved in the browser. So that's the header that's returned that includes any cookies that need to be saved, and the browser will handle those. There's also location, which will be used with a 300 level response to show what the new location is. So if the server returns like a 302 and says this resource has been moved, it'll include the location header to give you the new location that you should pull the data from instead. So that can be useful. So again, these aren't all of them, but these are probably the most common that are used. And again, we'll talk about how to handle some of those headers when we're talking about JavaScript and interacting with APIs, but we won't really deal with generating them because those headers are set by the server itself. So we don't really deal with the server side in this class. So we'll learn what to do with those headers, but we won't necessarily be changing them. So you've got the HTTP response headers, and then you've got the HTTP response body, which contains the main data that was requested in the request. It's typically HTML, so usually the response is HTML, but it could be JSON or some other data type, especially if you're working with an API. It may just return the raw data in some sort of data format. It could be an image if you've requested an image. Here's a couple of links too if you want to kind of read some more about HTTP. That was a very surface level. There's some crazy stuff going on behind the scenes. It's using TCP as a protocol beneath HTTP. So there's a lot more lower level you could get. That's kind of a very broad, high-level overview of how HTTP works. This is an example of an HTTP request in the command line. As it pulls up. So curl is a command line tool that just makes GET requests. So here's an example where we curled a website, mit.edu. So we can see a couple things. First, hostname was not found in DNS cache. So that means our browser or our computer doesn't know what the IP is. So that indicates that it's had to make a DNS request. So it makes a DNS request, and then it says trying, and it gives the IP address. So again, the DNS or the domain name points to an IP, and we really connect to the IP address. So then once we've connected on port 80, which is the default HTTP port. HTTPS uses 443. This is what kind of a raw HTTP request looks like. So we're making a GET request. The location of our GET request is /, so it's just the root of the domain. And we're also telling it what version of HTTP we're using. So 1.1 is probably still the most common. There's version 2 now that's pretty much finalized, and a lot of websites are enabling HTTP 2. So that's something to be familiar with. You don't really need to know the differences too much because it's mostly just dealt with by the browsers. So then we're sending 3 headers with our request. So we're sending our user agent, which in this case is curl because that's the program we're using, as well as the version of curl that we're using. We send a host as a header, so that's the domain name that we're making the request to. And we also send accept. So accept again is saying what types of response formats you allow. In our case, */* means anything. Like we'll accept any type of response. So whatever it is, we'll accept it. So that's our request there in red. Below that is the response from the server. So the server receives the request, it responds. It says, okay, I'm talking HTTP 1.1 to you. My response code is 200, okay. So it's a good response. Everything seemed to work fine. It then we see our headers. So we've got two server headers showing what version of Apache they're using, 1.3. It shows last modified, so this is when the website was last modified. We see our content type, so text HTML, so it's returning HTML in the response. It also will return the date, the content length, so it tells us how many bytes the content is, what the length of that content. That's useful for like if it's a file download, your browser can kind of estimate how long it'll take. That's how your browser says 10 minutes remaining. It's because it's responded with the content length even for a file download. So your browser can kind of calculate, okay, I know my internet speed's about this, so it's going to take about this long. So that's kind of what a raw HTTP response looks like, at least without, below that would just be the raw HTML at some point after all the headers. So you can try this on your own too if you want. If you do curl-v, I think curl is installed on Mac by default. It might be on Windows too, I'm not sure. And then some, website, it'll show you all of the HTTP communication, including what headers are sent back. Okay, so secure HTTP is really important to talk about. So at this point, most websites use HTTPS in favor of HTTP. Security is a really big deal now, and HTTPS will encrypt all your communication. So HTTPS is just a secure version of HTTP. It encrypts all communication between the client and the server. So every message that's sent back and forth, your entire HTTP request and entire response is encrypted. Everything except the URL, which is kind of important to keep in mind. So HTTPS requests begin with HTTPS, and they typically use port 443 instead of port 80. Again, we won't really have to know what port's being used, but it's good to be familiar with. Especially if you're setting up a web server and you need to set firewall rules, you'll need to open port 443 if you're going to support HTTPS. So without HTTPS, it's possible for outside parties to read, modify, intercept the data being sent between the client and the server. So outside parties just meaning anyone who has access to the network that your requests are being made over. So it could be like your internet service provider. It could be someone who's hacked into your internet service provider and is able to read traffic. It could be someone at a different level that's able to read that communication. About maybe like 6 or 7 years ago, there was a Chrome extension or Firefox extension that was released to really make it because HTTPS has only really become super popular in the last like 5 or 6 years probably. It used to be even Facebook was just over HTTP. So someone released a extension to show how dangerous it was, and what the extension did is if you're on a public Wi-Fi, so if you're on any Wi-Fi where it was just public, it didn't have a password, you could read the traffic of other people on that Wi-Fi network. So what the extension did would read that traffic, and it would look for cookies. It would look for requests to Facebook or Twitter, or even I think Gmail, and it would pull the cookies from those requests, and it would pull the authorization tokens from the cookies, which is the secure token that indicates that you're a logged-in user. So basically, this extension would start popping up if you're on public Wi-Fi. It would say, okay, here's a person named Steve who's logged into Facebook, and you could click on it, and it would log you in as Steve to Steve's Facebook. Because it was able to read the cookie being sent, and it can apply that cookie to your browser and start sending that secure token in your place, and now you're logged in as him. It's called session hijack, is what the type of attack is called, where you're able to steal someone's session if you have their session ID or their secure token. So that's a big deal, and it blew up. I think it got shut down within like 2 days because obviously it was a really big deal. The guy that made it was just trying to make a point that, hey, this is a big deal. Websites like Facebook should not allow users to log in and only use HTTP and not use a secure encrypted connection. So that honestly was a pretty big deal and sort of helped set the pattern of using HTTPS for everything. And if you think about it, even websites that don't involve a login, or websites that are don't seem like they need to be secure, if it's unencrypted, some sort of attacker that can intercept your traffic could modify the response as well. So they could inject their own HTML or their own JavaScript into the response. If it's just unencrypted in plain text, they can modify it, and they could install malware on your computer or something like that. So it's a really big deal to use HTTPS because it just encrypts everything. And again, it's becoming more common. A lot of websites now, if you go to like http://google.com, it'll redirect you to the HTTPS version of the site because that's how big of a deal it is. So with HTTPS, you will notice it changes. You'll notice HTTPS, and you'll also notice most browsers will turn the HTTPS green, and they'll show this lock icon just to give you this visual reminder that you're on a secure connection. And if you're interested, you can even click that icon, and you can kind of see some information about the connection. It's going to take a minute. I clicked on the green icon up there. You can click that little arrow. You can click on like more information here to see the actual, some of the identity information about the website. You can look at their actual security certificate if you want. So you can see that this is docs.google.com. It's verified by Google Trust Services, so Google has their own certificate authority. So you can kind of see some information about the certificate. You even notice sometimes, after the HTTPS will be like a big green bar that gives you the name of the organization. You'll see this a lot if you like connect to your bank. It'll say, Charles Schwab Bank in a big green bar. That's something that they've paid extra for. So they paid extra money to their certificate authority, and they've done some extra verification steps to provide that little green bar in there that tells you for sure that this is Charles Schwab and not anybody else. So again, this is just a quick representation. You connect to the server and you do some key exchange back and forth. It's called a handshake. We'll talk about that in a second. And now the client sees your name and your password and your data. In transit, it's all encrypted, so it's just gibberish. To anyone who's able to sniff on your network and read that data, they can't make any sense of it. Cryptographically encrypted and very secure. But then the server can unlock it, and they can actually read your information. I mentioned certificate authority a second ago. Slide changes. The certificate authority is responsible for issuing the cryptographic certificates that are used to verify that websites are trusted. They typically cost some sort of money. Usually you have to pay for an SSL certificate, is what it's called. And you usually have to do some sort of verification as well. At the bare minimum, you at least have to be able to respond to an email sent to your domain. So if you're buying a secure certificate for google.com, they'll send an email to admin@google.com or something like that, and you have to be able to respond and verify that that's you. A lot of times, especially for the higher levels of trust for a certificate, you'll have to do some additional verification or paperwork just to verify that you are who you say you are. So TAs are typically large trusted companies like Symantec is one. There's a couple other. If you just Google for certificate authority, you'll find a bunch. They work with the browser vendors and the internet providers to kind of establish trust. So your browser has a lot of certificate authorities already, configured in it, so it knows these certificate authorities. If a certificate says it's signed by them, I can verify it and I can trust it. So it's how we know that a website is who they say they are. I can't buy a certificate for google.com. It's just not going to be allowed because the certificate authority knows google.com is not me. They're in charge of verifying that. So when I see the certificate, here, it says docs.google.com, they're in that green lock. I know for sure that this website is really google.com because the certificate says so. They're able to provide the certificate. It's trusted. That's how you can verify for SSL or for HTTPS. Let'sEncrypt.org is a free one, so that's pretty new. It used to be it cost at least $20 to $100 to get a security certificate to do HTTPS, but Let'sEncrypt.org now is one of the first free ones. So if you're setting up a website, look into Let's Encrypt. It lets you get a free certificate. They do some automated stuff behind the scenes. So you can't just sign up on their website. You have to kind of work with your web server to make it happen. But it's a really great service. I've used them a bunch for websites that I'm not interested in paying a lot of money for, but I still want them to be over HTTPS. Important thing about HTTPS, it requires a handshake prior to sending your data, where the client and server agree on an encryption method, so they determine what type of encryption method they're going to use to encrypt the data. They also exchange public keys. So it's called key pair cryptography or public key cryptography is the method used. You can research that if you want. It's very complicated. It involves lots of math. But essentially, they're able to exchange public keys that allow them to encrypt messages sent to each other that only the other party can decrypt with their private key. So your computer has a public key and a private key, and Google server has a public key and a private key, and you can exchange public keys because if you only have half the key, you can't decrypt, but you can encrypt. So Google can encrypt the message and send it to you, and then you're able to decrypt it with your private key. It's very complicated. It's worth looking into if you're ever doing server-side stuff, but for our sakes, we'll trust the browser that they're able to handle that. So once you have those keys exchanged, you can work securely. Here's a graph or a graphic of kind of what that looks like. So the order here is a little wonky, but the first step is that the CA, or the certificate authority, issues a certificate to the server. So if I'm building a website, it's called kraighufstedler.com, and I want it to be secure, I go to certificate authority, I purchase a certificate, I verify my identity, I prove that I am Kraig Hufstedler or that I am the owner of kraighufstedler.com. So they issue a certificate that I then save on my server. Then if some client comes along and they want to visit my website over HTTPS, they will request identification. So the very first step of the HTTPS handshake is just saying, hello, I would like to connect securely. My server responds with the certificate, proving that I am kraighufstedler.com, as well as my public key. The client can then send their encrypted session key, so they encrypt session key with the public key of the server. The server can then decrypt that session key because it's been encrypted with their public key and they have the private key. They can then start encrypting messages back and forth with that shared session key. So again, you don't have to worry too much about the details. Don't worry about memorizing this, but that's generally how it works. So you do a handshake beforehand with the server, and once you've done that handshake, you now have the ability to connect securely and to talk securely, fully encrypted. An important thing to keep in mind is that these first couple steps of the handshake are not encrypted, as well as the URL that you're using is not encrypted, and also domain name requests, DNS requests, are not encrypted. So that's an important thing to keep in mind for privacy aspects. So say you're browsing the internet here on the WashU Wi-Fi, because if you're using HTTPS, WashU doesn't have a way to read the data that you're sending back and forth with the website, right? They don't have, if you go to facebook.com, they can't read your Facebook post unless they're inserting their own HTTPS, which does happen. Sometimes my work does that, so they kind of hijack your HTTPS and so that they can decrypt it because they want to make sure we're not sending company secrets, so they want to read our emails and stuff. It's kind of creepy. And it's not going to be possible at some point because they're changing the design of HTTPS a little bit to make it a lot harder to do that. So unless WashU is doing some really crazy stuff, they can't read the actual data as long as you're using HTTPS. However, what they can read is what websites you are visiting. WashU knows if you're going to facebook.com because they see in their logs, okay, here's a request to facebook.com. Here was a HTTPS handshake. They can't read the actual data sent, but they know where you're making the request to. It's also important to keep in mind that DNS requests are not encrypted, which means that they can be open to hijacking. So that's one of the most common methods. I imagine there's certain websites if you try and go to on the WashU Wi-Fi, it won't let you, right? I would assume. I've never tried, but I would assume there's certain things that are blocked. Typically, the way that they do that is by hijacking the DNS to their own servers that does not allow DNS requests to certain domains. So they may have some domain they don't allow. They block the DNS request to that domain. So your computer can never find out the IP address to that domain, therefore it can't visit it. That's typically how it works because, again, the data itself is encrypted, but they can hijack that DNS request and prevent you from finding the DNS entries for a specific domain. That's typically how that kind of filtering works. So, it's also
one of the biggest holes right now in web security is those DNS requests, because if a hijacker is able to intercept that DNS request, they could reply with their own IP address rather than the real Google.com IP address. So again, HTTPS at that point, they're not going to have a valid certificate, so they can't fully spoof Google.com, but they could at least redirect you to a different website or something like that. Okay, really quick here, because we're about out of time, a little bit about how websites are created. So HTML stands for Hypertext Markup Language. It provides the structure and the content of a web page, so most of your web requests will return HTML. CSS stands for Cascading Style Sheets, which provides the styling, and JavaScript will provide any sort of interactive features or dynamic features. Any sort of data manipulation or data fetching will happen with JavaScript. Your browser downloads the HTML from the web browser, and then the HTML includes all of the CSS and the JavaScript inside of it. So really the only thing that your browser gets is the HTML. It's all in the HTML, but it'll include the JavaScript and the CSS. We'll keep going. We'll pick up where we left off tomorrow. I want to show you real quick just an example of an HTTPS request just for fun. And then we'll get into a little bit more on HTML. So this is going to be on a delay, but if we do like curl, and I'll show you, let's make a curl request first to http://washu.edu. Might be kind of hard to read. Let me see if I can make this bigger. Yeah. So what's this? Date? We need to figure out something different. It's killing me. So we made a request to http://washu.edu. So first it has to find the IP. So it says trying, and here's the IP to the WashU servers. It's connected on port 80, because that's the HTTP port. It sends the host header and the user agent, which is curl. If you're using Chrome or whatever, that'll include all that details. Then here's the response that we get back. So we get back HTTP 302, which again is that, I think it's temporarily moved, right? They should probably use, there's a new one that you're kind of supposed to use in that case. But so they've returned a redirect, and they've given us the location, which is https washu.edu. So WashU does not want you accessing their website purely via HTTP for security reasons. Just in general, it's bad practice to do that. So they redirect us to the HTTPS version of the website through a 302 redirect header. So there's a few other headers here. They're using big IP, which I don't really know what that is. Content length is 0. There's no actual content here. They're not returning any HTML. They're just saying, hey, you need to go to HTTPS. So then, if we follow their instructions and we go to HTTPS, we scroll up through the HTML, we can see the HTTPS handshake. So here we've done curl on HTTPS. We followed their instructions and okay, we'll go to where you say. Do the same thing. Now we start, before we even send our headers, you'll notice there's no headers here. We do the TLS handshake. TLS is the software that's used to do HTTPS. It used to be called SSL, now it's called TLS. 1.2 is the current version. There's new versions every 6 months or so. TLS 1.2 is the current secure version, because the problem is people find security vulnerabilities in the software that manage it. So if you're using like TLS 1.0, someone can break in and read your messages back and forth because there's some sort of vulnerability in the way TLS 1.0 does that encryption. So you want to be using TLS 1.2 or else someone can read it. The CIA can still probably read it, even if it's TLS 1.2, but general people can't. So we start with the TLS handshake. The client says hello. The server responds with hello. So they said, okay, we want to talk HTTPS to each other. The the server also responds with its certificate, so meaning that it's coming into the client. The server also sends its key, so we see the key exchange. Then the server says, okay, I'm done sending things to you. The client, so out now, sends its key. The client also says hello encrypted. Now the client says I'm finished, and the server responds. It requests to change cipher, so the server says I'm not quite happy with the cipher you're using. There's quite a few different ciphers you can use. Some of them are more secure than others. They're always changing which ones are recommended based on, you know, what has been broken. So the server, the client or the server they have to agree on a cipher because that determines how they encrypt the data back and forth. And different devices support different ciphers. Different servers support different ciphers. So they've sort of negotiated the cipher here. And the server said, I want to change the cipher. I'm not happy with whatever one you said. So it responds saying change the cipher and also says hello encrypted. Then it's finished. So now we see SSL connection using TLS 1.2, and here's the cipher that they're using, which is a version of SHA-256. So if you're interested in cryptography at all, SHA-256 is kind of the best right now. And these are all the, just kind of the version of SHA-256 that's being used. So we can see the server certificate here. So we see like the issuer and stuff. We'll be done here in just a minute. So this is the certificate information. So we can see who it belongs to, including the address. We can see when the certificate expires, which is 2020, which is what you want. You want certificates that are long-lasting. We see who the issuer is, which is InCommon, which is the company that deals with universities and education entities. We've verified the certificate, it's okay. Now we can do our HTTP talking. So now we say, okay, now that we can talk on a secure channel, now that we've negotiated, an encryption method, I'm saying, here's a GET request, here's the host, here's my user agent, here's what kind of stuff I'm accepting. And then we can see what a full response looks like. So the server returns with HTTP 200 OK. It's got some stuff it's got expires. So here's the 24-hour. So they're saying this page expires tomorrow. Here's the content, which is HTML. Here's some cookies that they're setting. So they set this big IP server pool WordPress prod 80, which is the key, and the value is this. I don't really know what that does. Also don't know what this is. Again, cookies are completely arbitrary to the server. Typically, you don't even want to name cookies anything. Like if you go to Google and log in and look at the cookies, none of them really make any sense because it's something that the server uses internally. So you don't usually want to put like user ID as your cookie name because then, any sort of attacker knows, okay, there's the user ID cookie. So again, usually they're kind of nonsensical. And then we see the HTML that's responded. So they return all the HTML for the web page. So if we did this in a browser, we would actually see that rendered. So, okay, that's it. No homework for the weekend, so don't worry about anything as long as you were able to figure out the steps for the Hello World. And let us know if you have any questions. How's it going?
So you just want us to give us this URL?
Yeah. Yep, that URL, because that should be your public access.
Okay.
That's a good question. Yeah, what's up?
Cool. Oh, really? Oh, okay.
For the like extra point styling on this is just okay if we do it.
Yep. Yeah, that's totally fine.
So was CSS fine?
Yeah. Yep. Whatever you want to do.
Okay. And then the rest of it.
Yep. Submit in Canvas. So in Canvas you should submit your
No.
Yeah.
So like if
like I said,
like how would I be able to
anything
check
that's bolded, make sure you're
what
familiar with.
Canvas
I'll
is
usually
what I want?
send out a study
Is there
guide.
a way to
So
check if
review.
Canvas
So don't worry about it.
like no, how am I able to see what what Canvas is saying what I want on the whole?
Yeah, on Canvas you should be able to find them. There's a wiki that walks through how to
Cool.
If you have any questions,
Oh, okay, it does.
connect
Okay,
on
cool.
Slack.
Oh, it even gives you a screenshot. It's pretty cool. Okay.
So, and if you can't figure it out, shoot me an email and you can, I can help connect with you. But for this first time, I don't really care.
Yeah.
So,
Thanks. Thanks.
Yep.
That's our canvas usually just had like some of the entire zip file.
Yeah.
So I'm used to so many tabs.
Okay.
Use Canvas before stuff.
Well, no.
You're in it?
Wait, are any of you
Like extra stuff that I have to do.
There is for source tree. If you-
Okay.
On the
I'm gonna take
that
it.
wiki that walks through
I think I'm
the
gonna take
GitHub
4
stuff,
but
there's source tree instructions there as well. It's a separate page.
Because if I'm taking 347, I want to take 347 next semester.
Yep, sounds good. It's the same general process, it's just it's a little bit different. Yep. How's it going?
Yeah. I was like 20th on the
Oh.
wait list. 24th on
Yeah.
the wait list.
So,
And now I'm like
sorry,
number
say that
one
again.
on the wait
You
list.
mean Tuesday you
For
weren't?
347, and I debated about taking it, but
Oh, you know which section you're registered for? Okay, gotcha. Yeah, that's fine. Unless you wanted to change it. Would you rather do
What's
your
his
section? Okay, gotcha. Yep, no, you're good. If you're registered, it's totally fine.
okay.
Yep. Oh, what's up?
I have a question about modern philosophy. So,
Wait, really? Because like, yeah, I don't think.
I found that there's like.
So you're a tape for this interest. So
So I don't know.
I took
like,
one
whether
over it, and then I found out that this class was
affects
created
my
into
work.
I don't think so. I would probably just delete that file.
Okay, so giving you shouldn't prevent you from seeing like my.
Is that
Yeah, it
possible?
should. Nope. I don't know what that file is. So I would
Because like when I saw this, I was like, oh my god.
And if you
I'm
can
gonna
see the
learn
website,
HTML.
then we should work on it.
Look, I'm taking video game programming,
Yep.
which is like gonna be
Hey, how's it
great.
going?
So.
But yeah, I'm gonna go to Congress today to see like you know Canadian. Yeah, he said he thought it was
Yeah,
like
so
pretty straightforward.
we'll let you know.
I'm
We're
not
gonna
sure.
we'll send an email. There's a couple other students that we're in the other one. Because really it's just like the
Like, I know
four
art
assignments.
is-
So like the personal bio, the city guide,
Because I think Newman,
the
she said it was
Canvas
just
one,
one.
and then the WashU one are really the only ones that are similar. So we'll change them a little
And there's
bit.
no,
So,
like,
like instead of
other
the city
in-between
guide one,
class.
like a
Because like I'm taking like video game
7:21.
programming, I'm doing like an independent study.
So we'll let you know with each one what to do.
Okay.
Cool. Yep. And the quizzes will be pretty different, so I'm not too worried about that.
Okay.
Should be good. Thanks. What's up?
Just a question about like submitting it.
Sure.
After you submit it, does this
Use
Yeah, and you can click view in a new tab, which will open up, the actual page. Yeah. So.
that's alright.
Yep. That's good.
Thank you.
Yep.
It's just like everyone.
Hey, how's it going?
Pretty good, how are you?
Good.
I'm Claire, and I'm in the second section
Awesome.
of the class.
Nice to meet you.
So this weekend is my parents' 30th anniversary.
Okay.
And so they requested, / they are taking me and my brother to Disney with them to celebrate. So, and their birthday is like actually on Labor Day, so they didn't want to fly back on Monday. So I'm flying back Tuesday morning.
Okay.
So I might be late or miss this class.
Yeah,
Is that okay? Okay.
Not a big deal.
Great.
I post the slides on Canvas.
Okay,
So, yeah, because we'll probably just do lecture and then I'll give you the first assignment, the second assignment, but it'll all be on Canvas. So if you have any questions,
Sounds good. Thank you so much.
yep, no problem. Hey, okay. If you download the syllabus, it'll have most of what you need, as well as if you look on Canvas, there's a first assignment that's due later today, but if you need more time, it's just to go through all the steps of completing assignments. So, and there's a link to a page that walks you through all the instructions. So, if you have any questions, let us know. Me or one of the TAs, we can help you out. Yep. Chris, right?
Yes.
How's it going?
Good, how are you?
Good. And you were Julia.
Yes, I'm Julia.
Whew, good. Good. I'm glad I remember. How's your guys' summers?
Bad.
Yep.
Chill.
Yeah.
Yeah.
Good. Did you go home or stay here?
I'm from St. Louis.
Okay, sweet. That makes it easy.
Yeah.
That's awesome.
Yeah.
Where in St. Louis do you live?
Chesterfield.
Okay. I went to Marquette High School.
Oh, that's really close to me.
Okay.
Yeah, it's like down the street from me.
Okay, nice. Cool.
Yeah, I went to Parkway West.
Okay.
So,
Yep.
yeah.
Nice. Yeah, we lived in Baldwin.
Oh,
Like-
I live in Baldwin technically. But I say
Okay.
Chesterfield.
Yeah, that's where people know.
Yeah.
So we lived off of like Keeper Creek. It's like Clarkson, south of Manchester,
Okay.
and then like back in Marshall.
Yeah.
So it was pretty close to Ellisville, technically.
Yeah.
That's cool. That's awesome.
Yeah.
How's your summer, Chris?
It was good. I had like a program investment plan,
Oh, nice.
which was like cool, but also like 11 hours a day.
Oh, no, that sounds
We didn't
terrible.
get lunch break.
It sounds.
There was like that free eating advice while we were working. There was like tutor investments. It wasn't like this. I just deduct like lunchtime from my paycheck because I'm not taking it. Like I was scared of them sort of. Here we are. I finished the day at 1 here.
So, are you four going to be here for the second section? Yeah. Yeah. Okay, cool. Sounds good. I think there's a few less students in this section.
Yeah, I think it's capped at
They increased it to 60 for both of them. It was like 30 or something like that. So I think there's like 35 or something like that.
Yeah, the previous section says that like she's never used add or get help before, so she's really confused about the assignment. So I'm supposed to be working on it. Should have an extension.
Oh yeah.
Yeah, okay.
Yeah. The first assignment, it doesn't matter.
Yeah.
Yeah, okay, cool. Thanks for doing that.
Really worried about it.
Oh yeah. It's one of those things, it looks intimidating, but once everyone figures it out, once you
She
do
said
it
that
once.
she just wrote it on the notepad and then doesn't know how
Oh
to
yeah.
read it.
Gotcha. Make a note.
I don't know if she does that.
That's funny. We're going to give just an extra minute to stragglers. looks like you guys should be on. She said you should. I asked her to give you full access. Oh yeah. Okay, cool. I can probably check the roster too. I might not remember. Okay. There's Bartek. Oh yeah. Cool. All right. Good morning, guys. My name is Kraig Hufstedler. Thanks for being patient with me yesterday. We added this section kind of last minute, and I had a work thing I had to go to, so Aiden filled in and went over the syllabus. So if you have any questions about the syllabus, let me know. I'll stick around for a little bit after class. But yeah, I'm excited to teach web development. I've been doing web development professionally for probably about 10 years or so now. Worked in a bunch of different environments. I've done freelance. I've worked for small agencies. I've worked for startups. I've worked for large companies. I currently work for Enterprise Rent-A-Car. Their corporate headquarters are here in St. Louis. So I work on a project called Zimride, which is like a ride-sharing platform. So it's a pretty large web application. So I've gotten to do some fun stuff with scaling and stuff like that there. So yeah, I don't teach here full time. I'm an adjunct instructor. This is kind of a fun hobby, I guess you could say, for me. I really enjoy teaching, so I'm excited for the semester. But I probably do things a little bit differently than other professors. So bear with me if I do something wrong or if something's weird. Just let me know or just deal with it, and we'll be fine. I'm not too picky about most things, so just, if something's weird, just let me know and we'll figure it out. So yeah, this class we're going to cover mostly what we call front-end technologies. We'll talk about that a little bit in this lecture, but so we'll do the HTML and the CSS and the JavaScript. We're not really going to do any back-end programming, so that's stuff you should have done in, I guess in 131 you do some of that. Or there's some other classes that kind of handle more the back-end stuff, databases, that kind of thing. So we're only dealing with the front-end stuff that you see in the browser. So we're going to do a lot of CSS. We'll talk about some design stuff just a little bit. We'll talk about JavaScript. We'll eventually get into doing AJAX stuff, interacting with APIs. We'll get into React towards the end of the semester and kind of do some fun stuff with React, which is the JavaScript framework for dealing with the front end through web components. So it'll be a lot of fun. I don't think there's anything else I should cover. I don't think so. We'll go ahead and jump in then. Talking through kind of some introductory stuff. So first of all, as we're thinking, if you want to pull up the slides on your laptop, there's a YouTube URL in the syllabus. You can pull that up as a live stream on YouTube. I might actually change that because there's like a 10-second delay, and that's really annoying to deal with. So I might do something different. I'll let you know if I do, because I know there's a lot of seats that you can't really see the screen from. So sorry about that. If you want to pull it up on your own computer, you can follow me. I also post the slides on Canvas after class, so you can download them there too if you want to review anything that you missed. So the first thing, thinking about web development, we have to consider how people are accessing our websites. So obviously web browsers are the main way that people access websites. We've got Chrome, Safari, Firefox, and Internet Explorer. They're all a little bit different. They each kind of have their own quirks that we have to keep in mind. We also have mobile devices. So that's becoming a very large segment of mobile traffic. Probably about half and half on average now. Between all web traffic. Mobile devices present their own unique challenges. They have different screen sizes. Every mobile device is a little bit different. The pixel density, stuff like that. They also have different interaction behavior. You instead of a scroll wheel, you scroll with your finger, and that behaves a little bit differently. You can't hover on a mobile device like you can with a mouse. Also things like even the orientation, portrait and landscape, things change a little bit. So mobile devices have introduced quite a bit of a challenge for web development because we have to be able to take into account a lot of different scenarios with a mobile device. Plus tablets, a little different. So one of the things that we'll talk about is responsive web design, where our websites can handle incrementally different, sizes of pages and still look good, because there's all kinds of sizes out there between, a computer or a phone that's in, portrait mode that's pretty skinny to landscape mode to a tablet to a, full, like a laptop screen. Those are lots of different aspect ratios and lots of different sizes we're having to deal with, and we have to make sure our site looks good on all of those. One thing we have to keep in mind. The other thing we'll talk about a lot in this class is screen readers. So screen readers are software used by people with visual impairments or other disabilities that need the contents of a screen read aloud to them. So again, it'll read aloud the contents of a computer screen, not just websites. The Americans with Disabilities Act, or the ADA, provides some guidelines for designing websites to be used with screen readers. And in fact, a lot of times if you're working for a larger company or any sort of government organization, including most educational institutions, they require you to follow these ADA guidelines. And there's some laws that are going into effect here in the next year or two, in fact, that really require pretty strict adherence to these guidelines. So it's something we really have to keep in mind. There's unique challenges when your content is going to be read aloud. You have to make sure your HTML is formatted correctly. You have to make sure any images also have text content that go along with them if they're important. So that's a pretty big thing we'll talk about throughout the class as we talk about different HTML features. Wait for the delay. Trying to remember to hit it and then talk about it. It's going to take a minute. So this is kind of a breakdown. If you go to analytics.usa.gov, they provide you with analytics information for all federal, U.S. federal websites, which is really fascinating. It's really fun to look at. This is from 2017, from around this time last year. And so you can see the device breakdown. So it's about 55% desktop, 39% mobile, and about 6% tablet. I think now someone checked for me last class, it's at like 42% mobile for 2018. So it's grown 2% in the last year. That's likely going to keep growing a couple percentage points every year, if I had to guess. So again, less and less people are using, computers, traditional computers. A lot more people are using mobile devices for most of their web browsing. So you can also see the breakdown of browsers. So obviously Chrome is the most popular, followed by Safari and IE. Firefox, you can even see the version breakdown of IE. Edge is like the new version of IE, so they changed their naming from numbering to Edge. So that's the very newest one. You can also see the operating system breakdown. So Windows, interestingly, there's more iOS users than there are Mac users. So that's kind of interesting to see. So the whole point of looking at this is knowing that there's a wide variety of devices that we have to be able to present our websites to, including different combinations. You can have Chrome on Windows and Chrome on Mac, and they might be slightly different because Windows and Mac might render screens a little bit differently. So we've got a wide variety of devices we have to keep in mind. Browsers can behave slightly different. They all, in theory, follow the specifications of HTML and of CSS, and they should all, be the same. But the specifications aren't perfect. There's room for interpretation when you're looking at the specifications, and each browser does it a little bit differently. They all have, Chrome and Safari share the same rendering engine, but IE and Firefox each have their own rendering engine. So the software that actually draws the HTML on the page and determines how to size things, completely different. So there's little quirks to how they do things that we have to keep in mind. So we'll talk about how we actually do that as we go through the class. This next slide is from Google Analytics on a website that I've worked on for just a local church. So they have a little bit different demographics in their breakdown. I found this really interesting when I was looking at it. Their mobile is quite a bit higher. They have more mobile than desktop. It's almost reversed. It's a little bit more extreme than that even. They have 55% on mobile and only 37% on desktop. And so I thought a lot about that. I was like, why is there so different than government websites. And I think there's a couple reasons. For one, local companies and local organizations probably have a lot more mobile interaction because people are just pulling up their information on their phone to get information about what's going on or what their hours are or where they're located, things like that. So a lot more kind of quick searches. Also, if you're going to the IRS website to pay your taxes, you're probably not going to do that on your phone, I would guess. So a lot of official government interactions you're probably going to pull out your laptop for because there's more information you're going to have to type in. So even though, the federal analytics shows, more desktop, we have to keep in mind there's some websites where we're going to see significantly higher mobile usage. So in the case of this website, I put a lot of work into the mobile view because that was a big deal. Google Analytics is a great tool. You can add it to any website that you've developed. There's just a little JavaScript tag that you include, and then they let you see all this breakdown. It even goes further. You can see like age demographics. You can see location demographics. You can really get into the weeds on the demographics of your visitors. So it's really, really useful. You can even track like goals and different interactions and stuff like that. If you have questions, by the way, feel free to show up your hand or interrupt me, and I will answer it. So the internet works on a client-server model. We're going to talk a little bit about web servers and how where we put our websites to make them accessible. So clients are the browsers and the computers that are accessing a resource over the internet. So when we talk about front end and back end, front end is the same as the client. So it's the part that the user sees. It's the user coming to interact with the web page. Servers are the computers that host the resource. They're just computers. They have all the same hardware as your laptop, but it's specially configured and designed to be able to handle large amounts of traffic, to be really easily maintained, to stay cool, and they're usually really powerful computers as well. But when we talk about backend, that's the server side of things. So that's the server that's processing requests and returning the web page. So front-end development and back-end development is kind of a buzzword that's developed over the last few years. I think it's kind of most jobs I've had handled both. Most of the time we're dealing with the front end, we're dealing with the HTML and CSS, but we're also working on the back end. Some jobs are a little more siloed. Sometimes you'll only work on the front end, sometimes you'll only work on the back end, but that's what those terms mean. There's software installed on web servers that actually serve the web pages. So Apache is a really common one. Nginx is also becoming more popular. That's the software that actually processes a request and determines how to respond, determines what files to look up, or if it needs to run PHP, or if it needs to run Java, or whatever it needs to do. That's the software installed on the servers that handle those. Servers can also be any operating system, so Windows, Mac, and Linux all have server variants, so you can install Windows Server or Mac Server. Linux is the most popular, though, mostly because it's free, it's low cost, and it's pretty easy for remote management, so you can log in remotely and handle everything in the command line, which is typically how you handle things a little bit easier. So then web hosting companies will run large specialized servers for many, many websites. So they'll have racks and racks of servers that handle tons of websites on them, and they kind of manage everything for you. So if you want to run your own website, like I have a server at home that's just one little tiny server, and it runs one website, but like I don't run anything important on it because say the hard drive failed. Okay, I have to go buy a hard drive. My website's going to be down for like 2 days while Amazon ships me a new hard drive. I have to install it. I have to transfer files. It's really complicated to like maintain that hardware. Plus, it uses a lot of electricity. It runs my power bill up a little bit. It generates heat. That room that it's in is usually a little toastier. So web hosting companies take care of all these problems. One, they have full-time staff that manages things. They're really good at swapping out hardware if it goes down. They have specialized cooling and do water cooling and have giant fans and all this. So they kind of, do a really good job at managing those web servers. So it's not usually practical. Most companies are moving away from managing their own servers, and they're kind of outsourcing it to hosting companies. Or, here's a picture of a server. just for fun, this is what mini servers looks like. So each one of these little, horizontal things is a server and a rack. This is, so again, they're just computers. This next image shows the internals of one. So this is the inside, you can see the one unit of the server here. If you've ever built a computer or opened up the side of your computer, you probably recognize there's the hard drive, there's the CD drive, but you can even see the RAM here. So again, it's just the same thing that's in a normal computer. It's just specialized in a different format, and typically even a little bit more robustly built to be a web server. So for a website to be publicly accessible, it needs to be hosted on a public accessible server. Again, typically provided by a web hosting company. So like my server at home, it is publicly accessible because I've set up my router to allow, the outside to come in and to read it. So I can access it remotely. But typically, if you run a website on your laptop, unless you've set it up to be publicly accessible, I can't access your laptop over the internet, so I'm not going to be able to access the website on your laptop over the internet. So as I kind of mentioned before, web hosting is kind of an economy of scale, right? So the more you have and the bigger you are, the easier it is to manage things. So large data centers can manage thousands of servers. They can do cooling really well. They can have staff. They can even worry about physical security. So, if you have a web server that's going to host private, sensitive data like credit card information, you have to lock everything down. You have to make sure access to, those servers is controlled, because if someone was able to get into your server room and plug in a USB thumb drive and copy some files over, they could get some important stuff from that server. So physical security is a big deal. So again, it's much easily managed, in a centralized environment. Virtualization, by the way, anything that's in bold is maybe something you want to keep in mind. It might be covered on a quiz. Other than that, don't worry about memorizing too much, stuff from the slides unless you see something in bold. So virtualization is a software technology that allows servers to run many virtual machines. So it sort of allows you to abstract a server. So you can have a server with hardware, and then you can run many virtual servers that each run in their own kind of isolated environment on top of that server. And they have access to a portion of the host machine's resources. So, say you have a server with, 4 CPU, like a quad-core CPU, and, 32 gigabytes of RAM and a 500, or like a 10 terabyte hard drive or something. You can create virtual servers that have access to 1 CPU core and 8 gigabytes of RAM and 500 gigs of data, something like that. And you could run however many of those you can fit within your resources. You can also pool virtual servers across servers, so you can use virtualization to create a virtual server that has access to the resources of multiple servers. So like Amazon will do this. You can access more than just one server's worth of resources. So most web hosting companies operate this way. They create this kind of isolated environment for you that has access to some resources, but it's only a portion of what the underlying hardware is. So whenever you see like VPS, that stands for Virtual Private Server. That's a common term used for this. Hypervisor is the actual software that manages the virtual machines. So stuff like VMware or Zen are common virtualization things. One big downside is it introduces some security risk, and that's some of the largest security issues we've faced in web development over the last few years have been related to virtualization, because it's the only thing keeping you from, again, if you're one of 10, virtual machines on some hardware, if you're able to break out of the virtualization and access other data on that hardware, that's a pretty big deal. So there's been security vulnerabilities in these hypervisors that have allowed you to, see other customers' data or access, other stuff hosted on the same hardware as you are. So that's some, downside to virtualization. It's not, there's some risks involved. And we've seen that a lot. Some of the bigger hacks have been related to that. So related to virtualization is cloud hosting. So cloud hosting, the term cloud really just means like large. That there's big servers a large pool of resources that's virtually unlimited. So when you think of like Dropbox or something like that, which is a cloud service, it just means that when you create a Dropbox account, no one's going and plugging in a hard drive saying, okay, here's Craig's Dropbox account. It's all pooled together, and it's pretty much unlimited. You can upload however much stuff you want, and Dropbox has hundreds of thousands of hard drives plugged into their servers, and they can allocate it as needed by demand. So that's all the cloud really refers to, is this kind of global pool of resources that's available over the internet. So cloud providers usually provide some really nice features that provide scaling, because again, you can use however much you want. If you need more storage, all you have to do is upload the files or provision it. You don't have to worry about buying hard drives or anything. They provide some really useful management tools. Other services like DNS settings. You can do your networking all in the cloud. Databases, stuff like that. So some common cloud hosting providers are like Amazon Web Services, Microsoft Azure, Google Cloud. I think all three of these provide you with some free stuff. I know Amazon lets you run their like lowest tier of server for like a year for free. So if you want to, mess around with web hosting, or you want to kind of learn how to manage servers, Amazon's a really great place to go, because you can do it for free for up to a year. And then I think you can just create different accounts and still get the free. Then Google Cloud also has some a free tier. At the same time, one of the big pros for cloud services is you typically pay for what you use. So if for some reason you wanted to try something out on a really beefy server, you could spin up a server with a lot of resources, and you'll only pay for however long that server is active. So I did this recently. It was a project we were doing at work for fun, that we were doing some machine learning. And so machine learning is really resource intensive. It's also really more efficient on GPUs. Amazon Web Services actually provides you, one of the options for their virtualized servers is servers that have GPUs attached to them. And they have very large ones. So we would spin up like a virtual server that had like 20 GPUs attached to it. And we would run a machine learning task that took like 2 minutes, and then we would shut the server down. So we would pay maybe like a couple of dollars for a few minutes of a massive server. So that's a really nice feature that you can't really recreate on your own by buying hardware. You couldn't go buy tens of thousands of dollars worth of hardware and set it up just to run one task. But with AWS you can, and it's really cheap. So that's a really big benefit of cloud providers. It's also usually a little bit cheaper in the long run. I think even still, people are getting worried that at some point they're going to start raising their prices and it may become more expensive. But for now, it's generally cheaper to centralize all of that management and just kind of let AWS do the hard work for you. And then you just use their platform. It's also easier. Again, I spun up a massive server it took like 10 seconds to create the server, and it was available to me. Way easier than managing on your own. Also usually automatically managed, so again, they do all of the hardware configuration, they do a lot of the hard work for you. Again, there are some cons. We've got some security risk. Again, you kind of have to trust them when they tell you that you're in an isolated environment that no one else can access. You're like, okay, but there is some trust required there because there's some security risk. A lot of these now, AWS, for instance, lets you kind of supposedly run on your own private hardware, so you can pay extra and have your own dedicated servers within AWS, but that gets a lot more expensive. But really security-conscious companies will do that. They'll pay extra, especially once you're paying tens of thousands of dollars a month for your hosting. Amazon will kind of you're already using several servers worth of hardware anyway, so they'll isolate that for you. You also have some less control when you're using cloud providers. If you need really specialized hardware, or if you really care about specific aspects of the way it's managed, you don't really have control of that. You're really restricted to the options that they give you. So if you wanted to build some custom server that had a certain configuration, you can't really do that. You're restricted to what they give you. You also have vendor lock-in, which is a big deal. If you go with AWS and your service grows and you really buy into AWS's services and you use them and rely on them very heavily, it's kind of difficult to move away from them. And a lot of companies are finding this out recently. especially if it gets more expensive than you'd like, or you decide you'd like to bring it all in-house. There's some vendor lock-in involved. So something to keep in mind before you get too far. Any questions about anything so far? Okay. Splashed water on myself. I really suggest, especially if you're interested in, web development as a career, to, sign up for a free AWS or Google Cloud account and find some tutorial. If you just Google how to host a website in AWS or how to host a website on Google Cloud, you can find tutorials. Just walk through the tutorials and come to understand the steps involved, because you'll, probably have to install Apache or some sort of, web server software. You'll have to go through some steps of getting your files up there and figure out how to upload to it and how to manage things. And so it's really useful to kind of understand how that architecture works a little bit. Okay, so how websites work. So websites are accessed by a URL, which is called stands for Uniform Resource Locator. The URL consists of a few different parts. So the first part is the protocol or the scheme, which is the HTTP : or HTTPS for secure connections. There's a few other protocols. You might be familiar with FTP, which is like a file transfer protocol, or there's a few others. Even like Tor, if you've ever done like BitTorrent, that's technically a protocol that's not using HTTP. So HTTP stands for Hypertext Transfer Protocol, so you're transferring hypertext, which is just HTML. And HTTPS is for HTTP Secure. All data is encrypted between your browser and the server in HTTPS. And HTTPS should almost always be used. We'll talk about that a little bit more in a little bit. So after the protocol is the domain. So that's the main address of the website you're accessing, so such as google.com. It may include a subdomain like www, so if there's anything before like www. Or maybe like docs.google.com or something like that, whatever is before that dot is the subdomain. You can even have multiple subdomains as well. So, you could have, new.docs.google.com or something like that. You can have as many subdomains as it's configured to allow. The .com part is called the top-level domain, or TLD. So it can be many options. Up until a few years ago, all we really had were .com or .net or .edu, like .gov. But a few years ago, they opened it up. TLDs are managed by an organization called ICANN. So they determine, what these top-level domains are and who's allowed to use them. But they've opened it up. There's thousands of options now. So like .io is really popular. Like .website is one. Like there's literally thousands of options now for those top-level domains. So you can really kind of tailor it to your website. And that's managed by the your registrar. So when you register for a domain, you choose what top-level domain you want. So after the domain is the path and or the file name. So /folder and then /some file. It doesn't always include a file extension like HTML. HTML is the default. So if you just go to like google.com/search with no file extension, it's going to be HTML. But sometimes you will see a file extension on there, especially if you're just accessing a HTML file that's not generated by some sort of programming language, or if you're accessing an image or a PDF file or something like that, you'll see the file name. If you have a domain with no path, it's called the domain root. So if it's just google.com, you would call that the root of the domain. Something to be aware of. This next slide is a graphic that illustrates the URL anatomy. So again, first we've got the scheme, followed by the subdomain and the domain, then the top-level domain. You also can have a port sometimes. So if you ever work with like Node.js locally, usually it uses port 3000, so that's how you indicate the port. But 80 is the default for web traffic, or 443 if it's secure. So those ports aren't included, just because the browser knows how to handle it. So then you've got the path, and then you can also have a query string. We'll talk about that a little bit later maybe, but that's if you're providing some data along with your URL, like maybe if you're getting something with a specific ID, you can pass that ID through the query string. Then we also have a fragment identifier, so this will jump to a specific location on your web page. Again, we'll talk about that a little bit more when we get into HTML. Any questions on this? All right. So IP addresses. So your computer needs the IP address of a server that contains the website in order to download it. So this is what IP addresses look like. This is IPv4, which is kind of what you probably are most familiar with. As you can tell, there's not that many possible combinations, and every single device that's connected to the internet has an IP address, at least through a specific, like for instance, all of our devices here probably have the same IP address internet facing because WashU probably has a handful of IP addresses for that face the internet. All of your devices at home probably share one IP address, but generally, especially with mobile phones now, if you're on your phone and it's just on your LTE or something, it has its own IP address. So because we have so many mobile phones now over the last 5 years, it's exploded. We have Internet of Things devices now, so little devices everywhere that have internet connectivity. If your doorbell has the internet on it, it's got an IP address. So we're actually running out of these IPv4 addresses. I don't know what the official status is, if we are officially out of them or not yet, but there's only so many, as you can tell. So a few years ago, they finalized a specification for a new format of IP addresses that's hex encoded. So this is called IPv6. So you start to see this a lot more now. It's becoming a lot more common. And in the next few years, probably you'll start to see everything kind of switch to using IPv6 more and more because it's hex encoded. There's billions of different permutations available, so it's going to be a lot more flexible. But it is a little bit harder to read and understand because it's hex encoded. There's a lot of cool features with IPv6 too. If you're interested in kind of networking stuff, you should read up on IPv6 because they can be consolidated and shortened, and there's different ways to do masking. It's kind of an interesting format. So, but you don't have to memorize these for the class or anything. But after you've typed in a web URL like google.com, your browser first has to query what's called a domain name system, or a DNS server, which knows the IP for that domain. So it's sort of like an address book that correlates domains with the IP address of the server that hosts the website for that domain. So google.com exists on a server somewhere, probably exists on lots of servers, but there is one IP address that will take you to google.com. Probably an IP address to a load balancer that then redirects it to the specific server. But the domain name system is what's responsible for telling your browser what the IP address that it needs to make the request to. DNS servers are typically run by your internet service provider, so Charter or whatever will run domain name servers. Large companies like Google and Microsoft also have their own. Typically DNS servers all sync up. So all around the world, there's probably hundreds of thousands of domain name servers, and they sync up over time. They share information with each other. So like when you create a website, if you buy a domain and you set the IP address in the DNS settings for that domain, it may take anywhere from a couple minutes to a couple hours for everyone around the world to be able to find your website via that domain, because we call it propagation. So that DNS information, that mapping of domain to IP, takes a little while to propagate to all the servers because they only refresh every so often. So it takes a while for that information to make its way around. So it's something to keep in mind if you change the IP address of your domain. Keep in mind it may be a few hours before everyone will reliably get to the same place. Your browser also will cache DNS entries. So if you've gone to google.com once, it's made a request, it says, okay, I know google.com is this IP. Your browser or your computer saves that. It maintains a local database of those, so it doesn't have to make a DNS lookup every time. But it will refresh it every once in a while, as well as if you go to a new website, it may have to look it up. So here's a handy graphic of what that looks like. So when you put in some website in your browser, you first query the DNS server. You say, what's the IP of foobar.com? DNS server responds with the IP address. So now you can make the request directly to the web server with your URL. The web server will process and then return the response, the resource that you requested. Questions about DNS? Okay. So once your computer knows the IP address of the server that it's going to get the website from, it makes a request to the server for the URL. And at that point, HTTP, which is Hypertext Transfer Protocol, is a protocol that's used by the client and the server to talk to each other. So it's kind of like a shared language that they're able to use to make the connection and to transfer data back and forth. So there's multiple layers under HTTP. It's using TCP or UDP, at a networking level. It kind of gets deeper and lower level from there, but HTTP is kind of the top application layer protocol that's being used. So we'll talk about some details of how HTTP works. Typically the browser handles all the HTTP for you. All you have to do is type in, the URL and the thing and hit enter, and it handles all of this stuff for you. But especially as we get into JavaScript and we start interacting with APIs and we're doing AJAX and data fetching and stuff like that, we're going to have to deal with some of these details about how HTTP works. So we need to be pretty familiar with kind of some of the lower level details. So the first part of HTTP is the request. So that's your client sending the request out to the server. And those requests contain several parts. We've talked about the URL. We then have the request method, or sometimes called the verb. So it's the type of request being made. So we're saying this is, here's the URL, and then there's a type of the request. Get and post are the two most common. It's what we'll deal with in this class. So get is the most basic request of just requesting a resource. So it literally is saying get. So here's a URL. I want to get that resource. I want to fetch it. And it should only retrieve data. It's not making any changes. The server shouldn't, change anything to do a get request. It's what we call idempotent, where it doesn't make any changes. It just makes a request, and the server returns a response. Nothing changes. So if you're using a get request and to share data with the server, something like that, you shouldn't be doing that. You should only be using it for requests. We do submit data using post requests. So it will submit data to the server. So it's used for form submissions or writing a post on Facebook or sending a tweet. That's all where you're sending data to the server and you're requesting the data or the server to do something with that data. It's usually storing it somewhere. It may post it somewhere else for other people. But it's where you're sending information, the data. Those should all use post requests. There's a few other request methods. There's head and put. Head just gets the headers in the response. It doesn't get a response body. So it's a good way to check and see if a website's working or get some options. Put is where you would take a fully formed data object and you're telling the server, here's a data object. I want you to store it. So sometimes we'll see put, whereas post can be some fragment of data or something like that. So here's kind of an example of how we use HTTP verbs. Delete's also one we'll talk about here, but we won't really use it in class. But so say we're accessing some sort of store, we might make a get request to /store/inventory. So we're saying I want to see the inventory, return the response to the inventory. It's not making any changes. The store's not saving any data. It's just going to return with the inventory. Then we might say we see an item we like. There's an order button next to that item. We click the order button. Maybe we have to put in our name and our credit card details. Click submit on the order. Then we'd make a post request to /store/order. So that post would include the details of our order. So what items we're ordering, how we're paying, what the address is, that kind of thing. So that's where we're sending information, the data, or we're sending data to the server. The server's going to have to do something with that data, right? When we submit an order, the server probably saves it, probably processes our credit card, it probably triggers some sort of fulfillment, it's going to start packaging it. Something's going to happen as a result of that post request, right? So that's where we're sending some information. Then we could maybe do a get for a specific order. So we could say get /store/order and then some order ID like 1234. So maybe we want to like look up the details of our order to see if it's shipped yet or something like that. Again, we're making a GET request, so nothing's changing. We're not deleting the order. We're not editing it. All we're saying is we're fetching the information about that order with our GET request. But then maybe we can make a delete, which again is just another verb. It's less common, but it's in this example where we use the delete request method on the same exact URL that our GET is, right? So it's the same order ID, store/order/1234, but because we're making a delete request, the server knows that we want to delete that order. So it's the same exact URL, but it's a different HTTP request method that indicates the server should do something different. So it's going to actually delete it. We could maybe do a post to that order ID if we wanted to change it. We could do a post with a new address or something like that. So again, those verbs can play a big role in telling the server what to do, telling the server what we're wanting to do at that URL. So the next thing to talk about is the HTTP request headers. So headers are sent along with our request, and they contain kind of some meta information about our request. So this is not an exhaustive list. This is just a few examples. You don't have to memorize all these or anything. But it's important, typically your browser handles all these request headers. You don't, adjust them in your browser. But when we're dealing with JavaScript and making AJAX requests, we might need to change some of these headers. So they're important to be somewhat familiar with, that they at least exist and what kinds of things can be included in the headers. So like host is where we include the domain name of where the request is being sent. So if we make a GET request to google.com/search/ something we're searching for, the host would include just google.com. Accept is the type of media that we're requesting. So what types of response we accept. That's why it's named accept. So typically it's going to be like text/HTML, which is saying like, I'm making this request and I would like you to give me HTML back. Or I will accept HTML in response. Sometimes if you're wanting to download a file, it might be different. It might be like a JPEG or something like that. So you're saying, here's a request, I will accept JPEG data back. Accept language is saying what type of language you'll accept back. So typically it's going to be English, but that's where you're identifying what language your browser uses. And so the server knows what language to respond in. Cookies are really important. So cookies are data that the server has previously sent to us, and it's told the browser to save and then include with all future requests. So for instance, when you log into a website, once you've successfully logged in with your username and your password, the server will send a cookie to the browser that's some sort of token that verifies that you're logged in. It has your user information involved. It's basically like a secure cookie that it's like your login token. So then every request that you send, when you go to facebook.com and you log in, if you click on another Facebook page, you don't have to log in again, and that's because of the cookies. There's a cookie that has a secure token that gets sent to every future request, so Facebook can see that cookie in your header, and they know, okay, they're logged in, this is the user, we know that we can send them the data specific to that user. So there's all kinds of things cookies are used for. User or session IDs, security tokens. So if you've logged in, tracking information is used. So a lot of websites will track you. Google knows about other websites you go to because of your cookies. Other websites will inject Google cookies that they can track. So it gets kind of crazy. That's why you might have noticed like a few months ago, I think it was now, like every website ever had a big message about cookies. It's because the EU changed some of their laws regarding cookies because it's kind of a big deal with privacy, right? Like if you go to some, blog, they might know what your Facebook user ID is, and they might be able to tailor their ads to you based on your Facebook information, which is kind of crazy. And if it's not something that you've opted into, or if it's not something you're aware of, it can be kind of creepy when you start seeing ads related to something that you like on Facebook. If you like some page and you start seeing ads for it on another website, you're like, wait, how did that happen? It's because of cookies. It's because those, that website and Facebook have agreed to share cookies so that they can relate, your user data. So that's the EU kind of cracked cracked down on that, and they said, yeah, that's kind of creepy. You at least need to tell people that you're doing that so they can opt out of it, or they can at least know not to visit your website because you do these creepy things. So that's why everyone kind of scrambled. Even at my work, they're like the laws changed, and then they went into effect, and everyone was like, "Oh crap, we have to do the steps required to comply with these laws, especially if you do business in the EU at all." So that's where all those cookie notices came from. It's basically just informing you that they use cookies and telling you how to opt out if you wanted to. So cookies are a big deal, and those come through the request headers. That's how the website sets the cookies and tells your browser what cookies to start saving and to include. This is the request header. So these are cookies that have already been set, and you're sending them along with your request. They get sent with every request to that domain. User agent is a string of information about the client. So what kind of browser you're using, usually even what version of browser, what operating system, what kind of computer you have, sometimes even what kind of screen, sometimes even like what kinds of extensions you have installed or what capabilities your computer has. We've actually run into some privacy issues with user agents even because they're pretty uniquely identifiable. There's a website, I can't remember what it's called. It's like Browser Leaks or something like that that'll show you all the information your browser's sending about your computer. And if you correlate, like a specific browser version and a specific operating system version and, a specific extension version or something, you can kind of uniquely identify someone by that. So there's some privacy tools now that will change your user agent in the headers to either wipe it out or make it really generic. I use a custom one so that when I'm, debugging stuff at work, in my logs, I can see my own custom user agent. Like in my user agent, there's an extension for Firefox or Chrome that lets you change your user agent. So I've made mine like Kraig's computer. So in my logs, I can search for Kraig's computer, and I can see all the requests that my computer has made because that user agent shows up. Of course, every other website now knows that it's Kraig's computer. They know it's me, but that's all right. Content type we use with post and put requests where we're sending data, and it identifies the type of content we're sending in the request. So often it's like, JSON or URL encoded data, something like that. So next is the HTTP request body, which is only sent with post and put requests. Again, GET doesn't include any data, so GET doesn't have a body. All it is a request. But post and put requests, we're sending something to the server, so we have to include whatever data it is that we'd like to send along. It can be a variety of formats. Application/form URL encoded is often used for form data. So if you have a form on your website, when you click submit, it's probably sending a post request with that type of data with all of your form submission details. We can use JSON or plain text even. Those are all options. Again, we won't really have to worry. Well, we'll have to worry about these a little bit when we're doing AJAX and we're, sending information to the server via JavaScript a little bit later on in the class. So after the server has received and processed your request, so usually they have to, look up the page you're requesting, or if it's like a Java or a PHP app like WordPress or something, they're doing some, processing, running their PHP scripts to look up whatever you've requested. Then the server responds with an HTTP response, which contains several elements, the first of which is the HTTP response code. So it's a numeric value that indicates the status of your request. So 200 is successful. So if your request was good, the server found your resource and there are no errors, it'll reply with a 200 response saying everything worked out okay. There's also 301 or 302, which indicate that the resource is moved. So they'll say, hey, this is moved, you need to look somewhere else, the URL is changed. 404, which you might be familiar with, indicates that the resource wasn't found. So if you go to google.com/abcdefg whatever, that probably isn't a real page, so you're going to get a 404 response, and Google's going to say, yeah, I don't have a page called abcdefg. 500 is a little bit different. It indicates an internal server error. So if you go to google.com and you search for cats or whatever, and Google servers have an error, for whatever reason searching cats causes a bug in Google servers, it'll respond with a 500 error if things just break. So if you get 500 errors, typically it means there's a problem with the server itself. You may have caused that problem with the server with a bad request. I've run into this, in the application I work on for work. When we actually had some security testing a while back. So an outside security company started doing some automated testing of our website, trying to break into it. So they were just like sending all kinds of crazy requests, like making up URLs, and they hit a couple things that like something about the request broke our code. Like our code just didn't know how to handle that request, and it threw an error, so it sent a 500 response back. It's like that request caused a bug and something broke, and so here's an error. So typically 400 ones indicate a problem with the request, so your request is bad, something is wrong about the request, it doesn't exist. 500 typically indicates that something happened on the server and something broke. So again, there's more SAS codes than that. Typically 200 is good. There's even 100 level SAS codes, which are informational, but we don't really see those very often. 300 level are redirects of some sort. There's some new ones. There's like 307 and 308, which are different types of redirects. Again, some of the times they're permanently, it's saying, hey, like this is actually moved, you need to change your bookmarks or whatever. Sometimes it's just temporary. It's like, hey, this has changed for a little while, but it will later be accessible. Again, 400 is an error in the client, and 500 is an error with the server. So in the same way that our request includes request headers, the response also includes headers that provide some meta information about the response that's being returned. So again, these are just examples. These aren't exhaustive. Some of these you'll see pretty much all the time. Sometimes you'll see them occasionally. So age can indicate the age of the content if it's being returned from a cache. So it may say, this is a cached version of the page and it's a day old, so keep that in mind. Expires is kind of similar, but it indicates how long the browser can cache the page. So whenever you go to a page, your browser usually will try and save a local copy of that page. So like if you go to washu.edu, your browser is going to save a copy of that page, so that the next time you go to it, it won't have to download the page again. It can just load it from its local copy. But the expires header tells the browser how long to save the page for. So the WashU website has a day expiration of the cache. So what they're saying is the content shouldn't change for a day, or if it does, like it's not urgent that you have an up-to-date copy, because the main WashU page doesn't change all that often. However, like Facebook doesn't have an expires header, because Facebook never wants the browser to cache the page, because you should see fresh content every time you go to Facebook. Something like a news, like CNN.com probably has like a 5-minute cache, or maybe even 1 minute, because they're like, hey, it's going to update pretty quickly, and we want you to always have an up-to-date page. But maybe you've got a couple minutes, so subsequent requests can load the cached version. Content type will indicate the type of content being returned. It's usually going to be HTML. Content length tells you what the length in bytes, which is handy for like if you're downloading something. It'll tell you how big the file is, so that's how your browser knows about how long it's going to take to download, because the length is included in the header. The server header will indicate sometimes the type and version of the web server that's being used to respond to the request. So it might say Apache version 2.1 or whatever. We're actually finding there's some security reasons for the server not to tell you what version it is, because sometimes they find vulnerabilities in certain versions, and if they know that you're using that version, they say, okay, great, I can attack you using this method because that's a known vulnerability. So best security practice is to not include the server header in the responses. But you still see it from time to time. Set cookie is the server's way of delivering cookies to the browser for the browser to save. So if you see the set cookie header, it provides a key value pair that the browser will save, and then the browser will include in all future requests to that domain. Location as a header will be included with 300 level responses to provide the new location. So if the server responds and says it's a 302, the location is moved, it provides the new location for you. So usually your browser automatically will redirect. If your browser gets a 300 response, it says, okay, is there a location header? Okay, yeah, now we'll go to there. So you don't usually have to manually then go to that new location. Your browser just does it for you. Any questions about HTTP response headers? We won't really worry about generating these, but we may read some of these when we're dealing with APIs and doing stuff with JavaScript. So we've got the response status code. We've got the response headers that give some information about the response, and then we've got the response body, which contains the main data that was requested in the response. Again, it's typically HTML, but it can be an image or JSON data or some other type of file that we're downloading. If you want to read some more on HTTP, here's a couple of links that kind of go through things. Again, there's a lot more going on, sort of under the hood with the way web traffic works. There's networking stuff. There's a lot going on there. That's kind of a very broad overview. This is an example kind of just raw HTTP, kind of what it looks like. So this is done just in the command line using a tool called curl, which does GET requests for you. So if we do a curl on like mit.edu, we see first hostname was not found in DNS cache. So the computer doesn't have the DNS info for mit.edu saved. So it has to do it has to do a DNS lookup. It does the DNS lookup, and then it says trying at this IP address. So this is the IP address for mit.edu. So then it says connected to the IP on port 80, which is the standard. It's just HTTP, it's not HTTPS, so it's going to be on port 80. So then the client starts talking HTTP. You can see when the arrow points this way, it's the client sending out, and when the arrow points the other way, it's the server returning, reading the response. So this is our HTTP response, or request here in red. So first, we're telling the type of response, which is GET. This is the URL, or the location, which is just the root, so it's just / meaning just the root of the domain. And we have to tell it what version of HTTP we're using. 1.1 is kind of the standard right now, sort of slowly being replaced by HTTP 2, which is a pretty new protocol that has some changes. It's got a lot better security. So you may see HTTP 2 from time to time. Again, the browser kind of handles all that for you. We then see the user agent header. So these three are headers. So the user agent is curl, which is the software we're using. If we're using Chrome, it would say Google Chrome version, 80 or whatever it is they're on. But this says curl, and it has our curl version that we're sending. The host is the domain that we're making the request to. So again, between the host and the URL here, that's our full URL. So mit.edu and then the path, which is just root. If we were searching like mit.edu/schedule, here it would say /schedule. So those two things combined make up the full URL. Then we have the accept header, and this you can't really tell here on the screen, but it's */*, which just means anything. It's saying I'll accept any type of response that you give me, so it doesn't matter what you return with. So then we see the HTTP response. So again, it identifies that it's HTTP 1.1, returns with a 200 status code, and usually it'll give you some short, if it's a 200 level, it'll say OK, meaning it was successful. If it's a 300, it'll say 300 redirect, or 500 error, or something like that. Then it has the server header. There's two server headers here. This one has to do with SSL, but so it tells us we're using Apache 1.3. So again, if I were a hacker, this gives me some good information about the server I'm trying to hack into, because I know exactly what version it is, so I can look up vulnerabilities related to that version of Apache. Tells me I'm on Unix. It tells me the OpenSSL version, which is what does the HTTP security stuff. It tells me when the page was last modified. This E tag is just kind of an identifier. It tells me the content type, which is text HTML, so it's returning HTML. It tells me the date, the current date. It tells me the content length in bytes, so this is how big our page is, how much data it's going to give us. There's also this connection keep alive thing. And then below that would be our HTML that's actually responded in the body. So here you can see what the headers look like. Any questions about HTTP? Again, we won't be doing this kind of stuff in the class. We're mostly trusting the browser to handle all the HTTP stuff for us. It's just really good to be familiar with. Especially if you're going to do any sort of professional web development, you need to be kind of familiar with these concepts so that you can debug things, you can figure out problems. And especially if you're using JavaScript, we'll have to manually set headers sometimes and manually read headers that come back from our responses. Yeah.
Where would we find that page in our computer?
Oh, if you have a Mac, curl is installed by default. So you can do like curl-v, which says verbose, and then some URL, and it'll process that request for you. You can see it. I'll show you an example here in a little bit too. Okay, so secure HTTP. So HTTPS is the aptly named secure version of HTTP, which encrypts all communication between the client and the server. So everything is cryptographically encrypted. HTTPS requests begin with HTTPS : and they typically use port 443 instead of port 80. Again, you don't have to worry about that. It's stuff your browser handles for you. So without HTTPS, it's possible for outside parties to intercept and read or even modify the data being sent between the client and the server. So outside parties being anyone else who has access to read the network data. So without HTTPS, all of your requests and all of your response are just in plain text, and they're easily readable over the network. So it was around like 5 or 6 years ago, this really came to light because back then most websites didn't require you to use HTTPS even for logging in. Sometimes like their actual login page would use HTTPS, but then it would go back to regular HTTP once you were logged in. So there was actually a Chrome extension that somebody made 5 or 6 years ago that would sniff your Wi-Fi traffic. So if you're on public Wi-Fi that other people were connected to, and as long as there was no password on the Wi-Fi, then it was just all totally in the open, and you could sniff HTTP traffic from other people. And what it would do would pull authentication tokens from like Facebook or Twitter. So if someone had logged into Facebook, there's a cookie that's sent every time they go to facebook.com then that is an authentication token that proves what user they are. And in the Chrome extension, you would see all of these, Facebook users pop up and say, okay, here's Steve, he's on, your Wi-Fi and he's logged into Facebook, and you could click on it and it would steal that, it would just copy that session token, insert it into your own cookies, and you would be logged into Facebook now as Steve. So a pretty huge security vulnerability. You could be at Starbucks and you'd see everyone logged into Facebook and you just log in as them. So the extension got shut down in like 2 days because obviously it was a huge deal. But it made a big point, which is that like even once you're logged in, you should never be on regular HTTP. You should always be secure. Otherwise, anyone that can sniff your network traffic can steal sessions and log in as you and do all kinds of stuff. So it made a huge splash, and honestly, it was probably pretty instrumental in sites like Facebook and Google and Twitter now require HTTPS all the time. Even the WashU website requires you to be on HTTPS before you've even logged in. So it's really common now to only allow HTTPS connections. Otherwise, anyone can read. Even worse, people could modify it. You could intercept the traffic. You could modify, the HTML. You could insert some malicious JavaScript or something and install malware on the user's computer. You can do some really nasty things once you can, intercept that traffic. So HTTPS is a huge deal. And over the last few years, thankfully, it's become more and more common. It's a lot easier to get HTTPS certificates. So now most websites require HTTPS, even if they don't contain sensitive data. So again, if you go to washu.edu, you're not doing anything sensitive until you've logged in, but they still require HTTPS because someone could modify the contents or do something misleading. It's a pretty big deal. So you'll always know you're on HTTPS if it's green. Typically, most browsers make it green just as a way of reinforcing that you're on a secure site. They show a little lock there. If you click that lock, I'll click it here. It'll take a second to load, but you can actually see some of the information about the certificate. You can even, view certificate, and see some details. Click like more information, and then view certificate. Like that, you can see, that this certificate is for anything.google.com. You can see that the organization is Google LLC. You can see it's issued by Google themselves, so Google has their own certificate authority, so you're kind of trusting Google that they're verifying Google, which is maybe not a great practice, but they're big enough now, I guess we can trust them. We see that it expires in October 2018, so they're going to have to update their certificate pretty soon. Typically, when you buy a certificate, you want to get one that lasts as long as possible. So you can kind of see some details there. Close out of these. So, just super brief overview of how HTTPS works. Before you are able to send data back and forth with the server, you do a handshake, what's called a HTTPS handshake, and you exchange keys. So you send your key to the server. There's more that goes on here. But then once you've done that, you can see the data. So you can enter in like your name, your password, or other data, credit card details, etc. But you're able to lock it with the key that you've already exchanged. So in transit over the network, it's cryptographically encrypted. So it's just gibberish. It's just, it looks like a string of random letters and numbers. And it includes the headers, it includes the body. So all that sensitive data is completely unreadable while it's in transit from your browser to Google server. So, WashU, WashU IT, they can't read your data that's going back and forth between you and Google because it's secured. There's some ways that they can if they inject some SSL stuff. But in general, third parties can't read that data going back and forth. But once it gets to Google server, again, because you've exchanged keys, Google now can unlock that data and they can read it in plain text. So it's a way of securing all of your data while it's in transit. Any questions about HTTPS? Got a couple more things to go over and then be done. So a certificate authority is responsible for issuing the cryptographic certificates to trusted websites. So certificates, they typically cost some money to buy, anywhere from $10 to hundreds of dollars, depending on kind of what certificate authority it is, and there's different levels of them you can get. You may see, like this certificate, it just has a green lock, but you might notice if you go to like a bank website, it has a big green bar. Even try, I'm not sure if my bank has it or not, but like if you go to, yeah, so wait for this to update. Thankfully I'm not logged in, so you can't see my bank account, but yeah, so here, a lot of large institutions that require a lot of trust, they buy extra expensive security certificates for HTTPS that actually will include the name of the institution right there in the URL bar. So that's just kind of a feature that they use to, it just makes it seem a little bit more trustworthy because you can see right there what the organization is. Usually they'll provide you a little more information too if you click on it. So those are pretty expensive. They cost hundreds or even thousands of dollars. And they usually, to get that kind of a security certificate, it usually involves some paperwork and mailing letters and verifying your identity, because only Charles Schwab & Co. Inc. is able to have that certificate. They've verified. If you're on this schwab.com, you know it's Charles Schwab. So it's very secure, and it's a guarantee that it is that company. No one else can get a SSL certificate for that domain. So again, CAs are typically large, trusted companies. If you just Google, HTTPS certificate, you can find there's quite a few different ones. They work with browser and internet vendors. So usually your computer has a bunch of CA, what are called root certificates installed already. So it can kind of verify trust that way. Your computer knows about these certificate authorities. let'sencrypt.org is a free certificate authority. They've become popular in the last couple of years. It's super handy. So if you're building a website and you want to have security, you can use Let's Encrypt. It'll let you do it for free, so it doesn't cost any money, which is really nice. As I mentioned before, HTTPS requires a handshake prior to sending data, where the client and the server kind of exchange cryptographic information. They determine a encryption method to use and stuff like that. So this is kind of an overview of that handshake. You don't have to memorize this or anything. So step one, so say I want to make some website, kraighufstedler.com. So I have a server, I've got my website. I have to request a certificate from a certificate authority. So I say, okay, I want a security certificate for Kraig or Craigery or kraighufstedler.com or whatever. So the CA will issue the certificate to me that I install on my server. So then when someone on their computer tries to go to kraighufstedler.com, the first thing they do is they request identification. So they make a request. It'll use DNS and end up at my IP, and they say, okay, I want to go to kraighufstedler.com. Can you verify that I'm talking to kraighufstedler.com? So my server will respond with my certificate that I bought from a CA that proves that I am who I say I am, and I respond with my public key. So this is what's called public-private cryptography, like key pair cryptography. If you're interested in it, it's really fascinating how it works. But I send my public key over. The client can verify the certificate. So step 4 is that my client can contact the certificate authority and say, hey, here's the the hash of a certificate or the identifier of a certificate. Is this valid for kraighufstedler.com? Am I really talking to the right person? And the CA can say, yes, that matches our records. You are talking to kraighufstedler.com. So then the client sends, it creates a session key, which is the encryption key that's going to be used, and it can encrypt the session key with the server's public key. So it creates a session key, and then it encrypts it with the server's public key and sends it over. So then the server can decrypt it because it has the private key. Again, this is kind of how that cryptography works. So the server can decrypt that session key, and then it sends an acknowledgement, and now they can talk together using that session key that they've negotiated. So one way to think about it is that the server sends a box with an open lock on it that the server has the key to. The client then puts its own lock inside that box, locks it with the key that the server has, that the client doesn't need the key to, but they can lock it. So they send back this locked box with their open lock in it. Now the server can use their key to unlock that first box and pull out the client's open unlocked box. And it probably also has the key in it. So now the server can put the message in there, close it, lock it with the key they have, send it back. So they've got this shared key now. So that's in a nutshell how it works. It's a little more complicated than that. But essentially it's a way for them to then talk encrypted. We're going to stop here, but I'm going to show you an example real quick of what that handshake looks like using curl. So first I'll show you, again, if you're on a Mac, you can just do this. I don't know if Windows has curl installed by default, but on Mac you can if you're curious. So, and then -v is just a flag, that tells it to be verbose. So if we look for HTTP, washu.edu, so we're just connecting over HTTP, and we'll see what that looks like. So again, it says trying. So it didn't have to, do a DNS request because I've been to washu.edu before, so my computer already knew what the IP was. So it says, trying this IP, connected on port 80 because it's just regular HTTP. Here's the request that I'm sending. So I'm getting, the root on washu.edu. Here's my user agent. Again, it's curl, accepting any type of response. So here's the response now. So first, it's HTTP, but I get a 302 status code, which is that redirect. So it's okay, it's saying, it's moved somehow. Then it gives me a location header. So it says it's moved, but then the location is HTTPS. So this is how they're forcing you to go to HTTPS. They're replying with a 302 on HTTP and redirecting you to HTTPS. Stream offline. Oh, it's back. So the rest of these headers don't really matter because they've sent us this redirect. So now we say, okay, our browser will just automatically do that for us. But if we do curl with HTTPS, and then I'll need to scroll up because there's all kinds of HTML. There we go. The YouTubes are not doing so well. So we see our HTML, so we got a good response. Scrolling back up to the top. Okay, so we've done the curl on HTTPS. Uses the same IP, but now it's connecting on port 443. So now we have to do our HTTPS handshake before we do anything else. So here you can see what that looks like. So first, the client says hello. So my computer says hello to the server, says, hey, I want to, connect via HTTPS. The server responds with a hello. It passes in its certificate. It then passes in the key. So the server says, here's my public key. Then it says, okay, I'm done sending you things. Now the client responds with its key. The client says hello, but encrypted with the server's key. The client's finished. The server responds with hello. Interestingly, here, TLS changed cipher from the server. So one of the things they also negotiate along with exchanging the keys is determining a cipher to use. So to encrypt, they have to agree, because different browsers support different ciphers and different servers support different ciphers. And here's where the server actually responded and said, I don't like the cipher you're using, let's change to a different cipher. And they figure out, okay, that's fine. Yeah, question?
But they should be predetermined by the cipher.
There's a set of them that are predetermined, yep. And in fact, that's up here, cipher selection, so these are the ones that you're allowed to use. And they kind of just figure out the most efficient one to use. So here's actually the cipher they settled on. It's a SHA-256, which is the strongest. You can see some other details here. My YouTube is crapping out. So now, after the TLS handshake, you'll see the response headers. And then after that, you'll see all the HTML that got responded with. So again, if you just load that in your browser, you'll see the actual HTML. But in curl, we see just the raw HTML. So here you can now see the actual HTTP stuff that happens. So that's how TLS works. So that handshake happens. Now you can talk securely. No one else can spy in on you. Okay, that's it for today. No homework or anything for the weekend. So I'll